Yes, good evening students. So today we are going to do two chapters. One is D and F block elements and second one is aldehydes, ketones and carboxylic acids. So Ishaq sir is here to do D and F block elements first. Second session I will hand. Okay? Okay, have a good session.
Hi all, hope you are here, right? Can I see some emojis, some fire? Come on. Please make the chat active. I'll just wait for a few seconds. We can start soon. Please give me some emojis. I want to make sure my kids are here. Come on. Yes. Yeah, Ali, good evening. Rahman, sure. Hi. Some more. Chris, sure. Ani, yes. Anirudh, right. Saleha, Ali, Abhinav. Hope you are here. I'm not Dia. I'm not wasting time. I'm going for the chapter D and F block element. See, I want to make you sure that I will be discussing around 12 to 14 questions. It will not cover entire topic, I know. We have only limited coverage. I want to finish within one hour maximum. So I'm selected some 14 questions, but I'm sure out on 14, you can see 2 questions. The day after tomorrow's your board exam will be covering around 14, but out of 14, 2 will be there in your upcoming board. Guarantee. Starting. D and F block elements. I'll give a brief introduction overview, then we can start the topic. D and F block elements. Entire periodic table consisting of how many groups? 18 groups and 7 periods. 18 vertical columns and 7 periods. These 18 vertical columns are called groups starting from 1 to 18. Okay. Group number 1, group number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then 16, 17, 18. Group starting from, Ibnat. Group starting from first and second group, first group and second group is collectively called as S block elements. Whereas group starting from 13 to 18 is called as P block elements. And the remaining 3 to 12 is our group, which is calling it as D block elements, right? These D block elements may also called as transition metal. Why? They are called as transition elements, may also called as transition metal. Why? Because first group and second group are collectively called S block elements. Majority of the S block elements are metals. Whereas group starting from 13 to 18 is collectively called as P block. Majority of the P block elements are non-metals, but my D block is lying in a transition region, in a changing region from highly reactive metal to non-metal. That's why since the D block is coming in a transition region, transition state, or from metallic to non-metallic area, that's why D block elements are also called as transition metal, may also called as transition elements. Consisting of 4 series, calling it as 3D series, 4D series, 5D series and 6D series. For D block elements, last electron will be entering into D subshell, or they will be having incompletely filled D subshell. Caught? Will be having incompletely filled D subshell. Consisting of 4 series, calling it as 3D series, 4D series, 5D series and 6D series. Since D block elements are also called as transition metal, 3D series elements are also called as first transition series, 4D series may also called as second transition series, then third transition series, and 6D is called as fourth transition series. Okay. Anyway, 3D series starting from scandium to zinc. 3D series elements are starting from scandium to zinc, starting from scandium and ending in zinc. 4D series starts from yttrium, ending in cadmium. 5D series starts from lanthanum and ends in mercury. whereas 6D series starting from actinium and ensign copernicium having atomic number 112. Why these elements, why groups from 3 to 12 is called as D block elements? Because for them, last electron enters into D subshell. The D is actually inner DNA D subshell, or they will be having incompletely filled D subshell. You should know at least 3D series elements starting from scandium to zinc, which include scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Shortcut: Scooty Vikraman, Feko-Nikusen. Scooty Vikraman, Feko-Nikusen, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Why these elements are called as D block? Because last electron enters into D subshell, fine. But 14 elements coming after lanthanum, last electron is not entering into D subshell, last electron enters into F subshell, especially into 4F subshell, starting from cerium and ends in lutetium. These 14 elements are collectively called as lanthanoids. They are collectively called as lanthanoids. Similarly, 14 elements coming after actinium, in which last electron does not enters into D subshell, electron enters into F subshell, especially into 5F subshell, starting from thorium to lawrencium. They are collectively called as actinoid elements. These lanthanoids and actinoids are collectively called as F block elements, may also called as inner transition elements. Why they are called as inner transition? Because these F block elements are lying in between D block element, in between transit. That's why they are also called as inner transition elements. Okay, now continuing. So it's a brief, you got a brief idea regarding what is D block, right? So I mean, what is meant by D and F block elements? Entire periodic table consisting of 18 groups and 7 periods. 18 groups, 18 vertical columns. First group and second group is collectively called S block elements. Group starting from 13 to 18 is called as P block element. In between 3 to 12 is called D block elements, which is also called as transition elements or transition metal. Why? Because S block elements are metal, majority of the P block elements are non-metal. Since D block elements are lying in a transition region from highly reactive metal to non-metallic one, that's why they are called as transition elements, may also called as transition metal. Consisting of 4 series called 3D series, 4D series, 5D series, 6D may also called as first transition series, second transition series, third transition series, and fourth transition series. 3D says starting from scandium, ending zinc. 4D starting from yttrium, ending in cadmium. 5D series start from lanthanum, ends in mercury. 6D says starts from actinium, ends in copernicium, having atomic number 112. See why they are why these elements are coming in D block? Because for them last electron enters into D subshell. Okay, but unfortunately 14 elements coming after lanthanum, last electron is not entering into D subshell, entering into F subshell, especially into 4F subshell, starting from cerium to lutetium. They are collectively called as lanthanoids. Similarly, 14 elements coming after actinium, last electron is not entering into D subshell, entering into 5F subshell. They are starting from thorium to lawrencium. They are collectively called as actinoid. These lanthanoids and actinoids are coming under inner. They are called as F block elements, may also called as inner transition elements. Why they are called as inner transition? Because they are lying in a transition region, or they are coming in between the D block element. That's why they are called as inner transition elements. Can I go ahead? That's all regarding the intro part. Jaden, Farhan, Basila, who is that goes under? Aisha, Farhan, Ibnat. Hope you are there. I want to see some more names over here. Where? Reminding. Some more names is to become here, right? Respond, guys. Come. Okay, so continuing, I'm going with my first question, question number 1. My guarantee, my promise for you, out of 14 elements, 2 will be, out of these 14, 2 will be in your paper, damn sure, okay? I will not be covering complete, but I know, but whatever we are delivering, will be in a perfect, damn sure, okay? Question number 1. Yeah, Aisha, Abdurrahman, Asher, starting. Question number 1. Zirconium, read the question please. Zirconium and hafnium have almost equal atomic and ionic radii because of, options are given, diagonal relationship, lanthanoid contraction, actinoid contraction belong to the same group. Question clear? Farhan. Question clear? Lanthanoids or zirconium and hafnium have almost equal atomic and ionic radii. Why? Before that, see, what is meant by screening effect? What is meant by screening effect, shielding effect? Let's see, calling it as screening effect or shielding effect. What is meant by screening effect means every atom centrally contains a positively charged nucleus surrounded by so many shell, The last shell is called as valence shell. Electrons inside the valence shell is called as valence electron. Every atom centrally contains nucleus surrounded by so many shell. The last shell is called as valence shell. Electrons inside the valence shell is called as valence electrons. Shell lying in between the nucleus and the valence shell is called as inner shell, calling it as inner shell. Electrons inside the inner shell is called as inner electrons. I'm talking about screening effect, shielding effect, curtain effect. Okay, so what is screening effect means? Every atom centrally contains a nucleus, fine, surrounded by so many shell. Last shell is called as valence shell or outermost shell. Electrons inside the outermost shell is called as valence electron. In between nucleus and the valence shell is called as inner shell. Electrons inside the inner shell is called as inner electrons. This inner electron will act like a shield, will act like a curtain, will act like a screen. If a screen comes between nucleus and the valence shell, I am sure nucleus effect will not reach the valence shell, so attraction will be less. If attraction is less, size gonna big. Every atom centrally having a positively charged nucleus, okay, surrounded by so many shell called, and the last shell is called as valence shell. Electrons inside the valence shell is called as valence electrons. In between nucleus and valence shell, shells are called as inner shell. Electrons inside the inner shell is called as inner electrons. This inner electron will act like a shield, will act like a curtain, will act like a screen. If a screen comes, nucleus effect does not reach the valence shell, so attraction will be less or size gonna big. So I can say, if screening effect is more, size will be more. Think in opposite way. If there is no screen, if there is no shield, if there is no curtain, what we can say? Obviously, nucleus effect will reach the valence shell. So attraction will be more, size going to decrease. So I can say, if screening effect is less, size will be less. Who is screening means inner electrons are undergoing this screening effect. If a screen come, if a shield come, if a curtain come, nucleus effect does not reach the valence shell. No attraction means size gonna big. Think in opposite way. No shield, no curtain, no screen means I can say definitely nucleus attraction will reach the valence shell. More attraction means size will be less. That means if screening effect is less, size will be less. Simply, you can say in a one line that screening effect is directly proportional to size. That means more is the screening effect means more will be the size, less screening effect. Remember, who is screening? Inner electrons are undergoing screening effect, not valence electrons. They are the consequence, right? Because who is undergoing this shielding effect means done by inner electrons. Okay. Anyway, the order of screening effect is S greater than P greater than D greater than F. That means if inner electron is S, shielding effect will be more, size will be more. If inner electron is F, shielding effect will be less or size will be less. I hope you know that's called screening effect. Every atom centrally contains nucleus surrounded by so many shell. Last shell is called as valence shell or outermost shell. Electrons inside the valence shell is called as valence electron. Shells between nucleus and the valence shell is called as inner shell. Electrons inside the inner shell is called as inner electron. Will act like a shield, will act like a curtain, will act like a screen. If a screen comes, nucleus attraction does not reach the valence shell, so attraction less means size will be shortcut. Screening effect is directly proportional to size. And remember, the order of screening effect will be S greater than P greater than D greater than F means for if inner electron is S, screening effect will be more, size will be more. If inner electrons are F, screening effect will be less, size will be less. My topic for you is called the lanthanoid contraction. You can expect what is meant by lanthanoid contraction, explain its consequences. You can expect a question for 2 mark. What is meant by lanthanoid contraction? What are its consequences? What is meant by lanthanoid contraction means? In case of lanthanoid, starting from cerium to lutetium, even though lanthanum is not a member of lanthanoid because of close resemblance, lanthanum is also studied under lanthanoid. Remember, even though lanthanum is not a member of lanthanoid, but because of close resemblance, lanthanum is also studied under lanthanoid. That's why we can say lanthanoid means starting from lanthan lutetium. Okay. Now, what is meant by lanthanoid contraction means in case of lanthanoid, as we move from lanthanum to lutetium, there is a slow, steady decrease in atomic size. This slow, steady decrease in atomic size. This slow, steady contraction in atomic size is called as lanthanoid contraction. Reason, in case of lanthanoid, inner electrons are F. Since F is having very low screening effect, size will be decreasing. Hope it is clear. So what is meant by lanthanoid contraction means in case of lanthanoid, as we move from lanthanum to lutetium, there is a slow, steady decrease in atomic size. That slow, steady decrease or that contraction will be called lanthanoid contraction. Reason, in case of lanthanoid, inner electrons are F. F is having very low screening effect. If screening effect is low, size will be less. Hope it is clear. But your question, what is meant by lanthanoid contraction? Okay, slow, steady decrease in atomic size due to the poor shielding effect of F. That's okay. What are the consequences of lanthanoid contraction? Let's see the consequences of lanthanoid contraction. First consequence, I can say, because of lanthanoid contraction, 4D and 5D series element having similar size. Because of lanthanoid contraction, 4D and what is 4D, 5D, you know, what is 4D, 5D, you know, right? Anyway, because of lanthanoid contraction, consequences are, because of lanthanoid contraction, 4D and 5D series element having similar size, similar atomic size, similar ionic radii. Example, I can say zirconium is a member of 4D series. Hafnium is a member of 5D series. Zirconium and hafnium is having similar size due to this lanthanoid contraction. One more consequence. Question 2 mark. What is lanthanoid contraction? What are the consequences of lanthanoid contraction? First consequence is because of lanthanoid contraction, 4D and 5D series element having similar size. Okay, example zirconium, 4D, hafnium, 5D having similar size due to lanthanoid contraction. Second one is called as we move from left to right, atomic size is decreasing. Actually, oxen compounds are called as oxides. Oxen compounds are called oxides of different category called acidic oxide, basic oxides, amphoteric. We can focus mainly acidic oxides and basic oxide. Oxen compounds are called oxides. It's of different category called acidic, basic, neutral, amphoteric. Here I can say bigger atoms forms basic oxide, smaller atoms form acidic one. That is BB. Bigger atoms form basic oxide, smaller atoms. For example, here lanthanum is a bigger one. So lanthanum compounds are more basic, whereas lutetium is a smaller one. They will be more acidic or less basic. Second consequences of lanthanoid contraction is, as we move from lanthanum, lutetium, size is decreasing. Okay, that's fine. You know, oxen compounds are called as oxide. Bigger atoms forms basic oxide, BB. Smaller atoms form acidic one. Since lanthanum is a bigger compound, it will be more basic, or I can say lanthanum is a bigger element. Compounds of lanthanum called lanthanum hydroxide will be the more basic one, whereas lutetium hydroxide will be the more acidic one or less basic one. More acidic one or less basic one. Hope it is clear. Now my question. Zirconium and hafnium have almost equal atomic and ionic radii because of the reason called lanthanoid contraction. Go with option B. Hope it is clear. Can I see some more emojis? Yeah, Brighty, Dia, Mohammed, Pranav, Akshay, Aisha, Hamdan, Fars. Clear. Can anyone say how many people are here in the live right now? Chat please, anyone. How many people in the live right now? Can you the number of that people in the live right now? Just comment please. I'm continuing. Second question. Cu plus ion is unstable in aqueous solution because Cu plus ion is not stable. Question: Cu plus ion is not stable in aqueous solution because, let's see. Yes, Cu plus ion is unstable in aqueous solution because in aqueous solution, Cu plus undergo disproportionation to become Cu2 plus and Cu. What is meant by disproportionation means same element undergoes both oxidation and reduction. Sure, fine. Dia, Asher, fine, Farhan. Okay. I got that, fine, thank you. Now come back my question. Cu plus ion is not stable in aqueous solution because, yes, Cu plus ion is unstable in aqueous, or question may also come like this, which ion is unstable in aqueous solution, Cu plus or Cu2 plus, or question may come like this, why Cu plus ion is not stable in aqueous solution? Reason: Cu plus ion undergo disproportionation. What is disproportionation? Same element undergoes both increase and decrease in state is called disproportionation. Here Cu plus changes into Cu2 plus and Cu. State of copper is plus, state of copper is 2 plus, and here state of copper is 0. So plus 1 to plus 2 is increase in state. Increase in state is called as oxidation, but same copper also undergo plus 1 to 0. Plus 1 to 0 is decrease in state. Decrease in state is called as reduction. So here same element undergoes both increase and decrease, which is called as what? A disproportionation. My question: Cu plus ion is unstable in aqueous solution. Why it is unstable? Sure, why? Because it undergo disproportionation reaction. What is disproportionation means? Same element undergoes both increase and decrease in state. Because of disproportionation, Cu plus changes into Cu2 plus, and actually when Cu plus changes into Cu2 plus, size is decreasing. Charge is increasing means size is decreasing. If size is decreasing, hydration enthalpy. What is hydration enthalpy? Wait. If size is decreasing, hydration enthalpy will be increasing and stability will be increasing. In one line, I can give you a shortcut lot. Stability of a species. Stability of a species is directly proportional to hydration enthalpy, which is inversely proportional to size. That means if Cu plus changes into Cu2 plus, charge is increasing, size is decreasing, hydration enthalpy is increasing, hence stability will be increasing. What is meant by hydration enthalpy means? This all process happen in aqueous medium. In aqueous medium, molecules are get hydrated. Okay, during that hydration, some amount of energy will be liberating. That energy is called as hydration enthalpy. Energy is liberating means in size, stability will be increasing. Or I can say, if energy is increasing means stability will be decreasing, or energy is decreasing means stability. Simple example, alcohol, it's energy. Not energy, it's energy. So alcohol is increasing means stability gone down. But that means energy is increasing means stability is decreasing. Okay, so in what happen means if size is less, this all happen in aqueous medium. If size is less, I can easily hold more, water can easily hold the molecule. If size of species less, water can easily hold the molecule. So during that holding, energy will be liberating. When size is less, I can say more number of water will be holding. During that holding, during that hydration, energy will be liberating. Energy liberated will be calling it as hydration enthalpy. Energy liberating means energy decreasing means stability is increasing. Hope it is clear. Question for you: Cu plus ion is unstable in aqueous solution. Why? Because Cu plus undergo disproportionation to become Cu2 plus and Cu. Disproportionation means same element undergoes increase and decrease in state. When Cu plus changes into Cu2 plus, state is increasing. Increase in state is called as oxidation, but when changes into Cu, state is decreasing. Decrease in state is called reduction. Same element undergoes both increase and decrease called disproportionation. Actually, when Cu plus becomes Cu2 plus, charge is increasing, size is decreasing, hydration enthalpy is increasing. Hydration enthalpy is energy liberated during hydration. Energy liberating means stability, because in science, energy is more means stability gone. So energy decreasing means stability will be increasing. That's why it undergo disproportionation, because of high negative hydration enthalpy or more energy liberation. So option A. Second ionization enthalpy of copper is lesser than that of first ionization enthalpy. B, large value of second ionization enthalpy of copper is compensated by much more negative hydration enthalpy of Cu2 plus. It's an F. For a 1 mark or 2 mark, your answer should be yes, Cu plus ion is unstable because it undergoes disproportionation. Disproportionation means same element undergoes increase and decrease in state. When undergo disproportionation, Cu plus will become Cu2 plus. So charge is increasing. Size is decreasing. Hydration enthalpy increasing. Stability is increasing. More stability means it will be more happy, right? Go with option B. Are you okay? Fatima, sure. Can I go ahead, please? Can I give something? Give me something. Okay, Hamdan, Farhan, Hanasha, Abdullah. Can I continue? Option B will be the right answer. Next one. For this kind of question, read the question for a second. E0 value of Mn3 plus bar Mn2 plus is highly positive than that of E0 value of Cr3 plus bar Cr2 plus or E0 of Fe3 plus bar Fe2 plus because. Question. E0 value of, simply speaking, E0 value of Mn3 plus bar Mn2 plus is highly positive. Why? If a question come like this, why electrode potential is positive? Or why E0 value is negative? Your answer should be in two ways. I'll tell you. First way, if E0 value is negative means you can say they will undergo oxidation. They will undergo oxidation. Undergoing oxidation means, can anyone give the condition for oxidation? Tell me. Zuhara, sure. Can anyone give the condition for oxidation from my chat box? Can me. Not the option. I'm asking, give me the condition for hydration. The guy giving condition, I'll give super reward, sure. Condition for oxidation. Give me, please. At least one guy, come on. What's the reason behind? Why E0 value negative means undergoes oxidation? Okay. Give me condition for oxidation. The first member will be whom? Jaden, Zuhra, Farhan, Sanush, Akshara. Give me the condition for oxidation, please. No condition. Okay, then I'll give the condition. See, this kind of question can approach in two ways. I told you E0 value negative y or E0 value positive y. Your answer should be like this. E0 value negative means they will undergo oxidation. There, Ibn, sure, yeah. Ibn from MES, clear. Because, yeah, sure, I can say E0 negative means undergoing oxidation. Oxidation means for undergoing oxidation, hydration enthalpy should be greater than sublimation enthalpy plus ionization enthalpy. Yeah. Brighty, okay, but first answer is given by Ibn. Thank you, Ibn. So E0 value negative means question will be coming like this. Why E0 value negative? Why E0 value positive? E0 value negative means they will undergo oxidation. Undergoing oxidation means I can say hydration enthalpy is greater than sublimation plus ion. What is sublimation? It's a capsule revision. If you want message me, I can give a detailed answer, but it's a capsule one. I can say for oxidation, hydration enthalpy is greater than sublimation enthalpy plus ionization. Okay, similarly, if E0 value is positive, it will undergo reduction. Undergo reduction means I can say hydration enthalpy is lesser than sublimation enthalpy plus ionization enthalpy. That's one way of answering. One more expression I'll give, just wait. So if any question come, why somebody is E0 value negative, why someone is having E0 value positive, answer should be E0 value negative means undergoes oxidation. Oxidation means for them hydration enthalpy will be greater than sublimation enthalpy plus ionization enthalpy. E0 value positive means they will undergo reduction. Reduction means you can say hydration enthalpy is lesser than sublimation plus. That's one way. One more way for this question. E0 value of Mn3 plus bar Mn2 plus is positive, highly positive. Positive means what we can say, they will undergo reduction. They will undergo reduction means I can say for them hydration enthalpy is lesser than sublimation enthalpy plus ionization enthalpy. Okay, that's one answer, but I'll give you one more answer. Since E0 value positive, reduction, okay. What is reduction means? Decrease in state. Decrease in state means what? 3 to 2 or 2 to 3? 3 to 2, because 2 is the most stable state of manganese. You can answer in two ways. E0 value positive means undergoes reduction, fine. Why they undergo reduction? Because for them hydration enthalpy is lesser than sublimation plus ionization. Okay, one more answer for you. E0 value positive means undergoes reduction. What is meant by reduction means decrease in state. Decrease in state means what will be? 3 to 2, 2 to 3, 3 to 2, because 2 is the most stable state. Because 2 is the most stable state. Example, you know manganese. It's my manganese. In case of manganese, atomic number is 25. 25 means configuration will be argon 18, 4s2 23d5. Mn2 plus means 2 electrons are gone. That 2 will be gone from 4s. Remaining will be 3d5. Yes, Mn2 plus is highly stable because 3d5 is halfly filled stable configuration. Hope you are fine. So come back to my option. So whenever E0 related questions come, you can answer in this way. Why E0 value positive? Reduction, that is hydration enthalpy lesser than sublimation. Or why E0 value negative means oxidation. So hydration enthalpy is greater than sublimation plus ionization. Okay, one more way. E0 value positive is reduction. Reduction means decrease in state. Decrease in state means 3 to 2 because 2 is the most stable state, because in manganese Mn2 plus is having 3d5 halfly filled stable configuration. My options are question E0 value of Mn3 plus bar Mn2 plus is highly positive than that of E0 value of something. What's option? Mn2 plus can easily oxidize into Mn3 plus. No, it's wrong. Plus 3 to plus 2, not plus 2 to plus. It's wrong one. Second one, the third ionization enthalpy of Mn is much more larger due to stable. Yes, since stable D5 configuration, Mn2 plus will not become Mn3 plus because Mn2 plus itself is highly stable. That means due to stable D5 configuration of Mn2 plus, 100% sure go with option B. Continuing, question number next one. Hope I'm doing in a correct pace. What do you say? Want to tell him something? Farhan, sure. Now next question. When acidified K2Cr2O7 solution is added to SN2 plus salt, then SN2 plus changes to. Yeah, Jaden, sure. See, before that, what is meant by acidified K2Cr2O7? That is K2Cr2O7 in presence of acidic medium. K2Cr2O7 contains ion called Cr2O7 2-, which is called as dichromate ion. That dichromate ion in presence of acidic medium changes into Cr3+. K2Cr2O7 contains, it's called potassium dichromate, having an ion called Cr2O7 2- called dichromate ion. In acidic medium, it will changes into Cr3+. When Cr2O7 2- changes into Cr3+, here state of chromium, I don't know, taken to be X. Here we have 2 chromiums, so 2x within the compound. State of oxygen is -2. -2 into 7 is -14 is equal to -2. So I can say 2x is equal to -2 plus 14. 2x is equal to 12. X is equal to +6. State of chromium is +6. In acidic medium, Cr2O7 2- dichromate ion changes into Cr3+ means what? Oxidation state of chromium varies from 6 to 3. 6 to 3 is called decrease in state. Decrease in state is called as reduction. The one which undergoes reduction will be calling it as what? Oxidizing agent. That means Cr2O7 2- called dichromate ion in acidic medium is a powerful oxidizing agent. Why? Because in acidic medium, Cr2O7 2- changes into Cr3+. When Cr2O7 2- changes into Cr3+, oxidation state of chromium varies from 6 to 3, decrease in state, calling it as reduction. The one which undergoes reduction will be calling it as oxidizing agent. One more definition for you. What is meant by oxidizing agent? Undergoes reduction, ulta. That means the one which undergoes oxidation will be called reducing agent. One which undergoes reduction will be called what? Oxidizing agent. One more definition for you. Oxidizing agent helps in oxidation, but it will not undergoes oxidation. It will undergoes reduction. Oxidizing agent helps in oxidation, but he will not undergoes oxidation. He will undergoes reduction. Or ulta, reducing agent helps in reduction, but he will not under reduction, but he will undergoes oxidation. Simple example. A travel agent helps in traveling. He will not travel. A travel agent helps in traveling. He will not travel. So oxidizing agent helps in oxidation, but he will not undergoes oxidation. He will undergoes reduction. Simple example. Cr2O7 minus. Cr2O7 minus in acidic medium changes Fe2 plus into Fe3 plus. It changes SN2 plus into SN4 plus. It changes I minus into I2, changes H2S into S. One more clarification. Acidic medium Cr2O7 minus changes into Cr3 plus. Okay. When Cr2O7 minus changes into Cr3 plus, oxidation state of chromium is decreasing. Decreasing state is called reduction. The one which undergo reduction will be calling it as oxidizing agent, or oxidizing agent will undergo reduction. Or one more definition, travel agent helps in traveling. He will not travel. For example, oxidizing agent helps in oxidation. He will not undergo oxidation. He will undergo reduction. That's why my dichromate ion, yeah, Leon, travel agent, sure. Cr2O7 minus dichromate ion in acidic medium changes Fe2 plus into Fe3 plus. When Fe2 plus changes into Fe3 plus, oxidation state of Fe varies from 2 to 3. 2 to 3 is called increase in state. Increase in state is called as oxidation. Take place with the help of an oxidizing agent. That oxidizing agent is Cr2O7 minus in presence of H plus. He will not undergo oxidation. He will undergo reduction to become Cr3 plus, and the byproduct is water. Balance reaction. Please can expect this for 1 mark. Reactant given, write the product. One more example. My dichromate ion Cr2O7 minus in acidic medium changes SN2 plus into SN4 plus. When SN2 plus changes into SN4 plus, oxidation state of tin SN varies from 2 to 4. 2 to 4 is called increase in state. Increase in state is called as oxidation. Take place with the help of an oxidizing agent. That oxidizing agent is Cr2O7. He will not undergo oxidation. He will undergo reduction to become Cr3 plus, and the byproduct is water. And the byproduct is water. One more example. Last one. Cr2O7 minus, calling it as dichromate ion in acidic medium, changes I minus into I2. When I minus changes into I2, oxidation state of iodine varies from -1 to 0. Minus, it's not balanced, sure, but you can balance. SID, who's that? -1 to 0 is increase in state. Increase in state is called as oxidation. Take place with the help of an oxidizing agent. That oxidizing agent is Cr2O7. He will not undergo oxidation. He will undergo reduction to become Cr3 plus, and the byproduct is water. So your question, please. When acidified K2Cr2O7 solution is added to SN2 plus salt, SN2 plus changes into SN4 plus, I minus changes into I2, Fe2 plus changes into Fe3 plus, H2S changes to S. So go with SN2 plus to SN4 plus, option C. Yes. Yeah. Yeah, sure, okay, SN4 plus. Can I continue? Let's, next one. Composition of mish metal. Who is mish metal? Mish metal is an alloy. Alloys are mixtures of metal. Who is mish metal? Mish metal is an alloy. Alloys are mixtures of metal. Actually, mish metal contains 95% of lanthanoid elements, and will be having 5% of iron, and will be having traces of minute quantities of sulfur, silicon, carbon, calcium, aluminum. It is used as a flint. What is flint means? Flint is spark producer. You can see in cigarette lighters that wheel one, that is called as flint. a spire producing agent or spark producing agent. So question, composition of mish metal is. Mish metal is an alloy. Alloys are mixtures of metal. Mish metal contain 95% of lanthanoid element, 5% of iron, traces, minute quantities of sulfur, silicon, carbon, calcium, aluminum used as a flint. Flint means spark produce. You can see that cigarette like that, wheel of that cigarette right there. So option 95% of lanthanoid, 5% of iron, traces of sulfur, carbon, calcium, aluminum. Go with option D. A. Why A? Rian. It's D, bro. 95% is lanthanoid. Russell, okay. Dania, Christopher, Abdullah, Jaden. Fatima, D, right? Okay. I'm continuing. Next one. Before this question, a metal will show highest oxidation state with the oxygen and fluorine. Why? A metal will show highest oxidation state with the oxygen and fluorine. Why? Because oxygen and fluorine are the most electronegative element. Since they are the most electronegative, they will be taking maximum number of electrons from metal. Correspondingly, the oxidation state of metal increases. Okay. A metal will show highest oxidation state when comes with the oxygen and fluorine. Why? Because oxygen and fluorine are the most electronegative element. Take maximum number of electrons from metal. Correspondingly, the oxidation state of metal increases. Okay. But among oxygen and fluorine, people may think like fluorine is more electronegative. So with the metal will be showing highest state with fluorine, but answer is wrong. A metal shows highest state with oxygen fluorine. Okay, because oxygen fluorine are the most electronegative element. Since they are the most electronegative element, take maximum number of electrons from metal. Correspondingly, the oxidation state of metal increases. Okay, but among oxygen and fluorine, people may think fluorine is most electronegative. A metal will be showing high state, but answer is wrong. A metal will be showing high. Among oxygen and fluorine, a metal will show highest state with oxygen, because oxygen can make multiple bond. Yes, I'm getting good response. So happy to have this life. Hamdan, Abdullah, much appreciated. Thanks all for the food. Yes, yeah. Mish metal, refer bro, mish metal. I'll pass side for you. Mish metal, right? Only covered before. Yeah, I'm done. So once again, a metal will be showing high state with oxygen fluorine. Why? Because they are most electronegative, taking maximum number of electrons from metal. Correspondingly, metal will show higher state. Okay, among oxygen and fluorine, a metal will be showing high state with oxygen, because oxygen can make double bond, multiple bond. Fluorine can make only single bond. My question. Ability of oxygen to stabilize high oxidation state exceeds that of fluorine. Yes, because a metal is showing high state with oxygen, not with fluorine. Because oxygen can make multiple bonds. So assertion right. Reason given, highest oxidation number in the oxides coincide with the group. It's actually a good statement, but it's wrong. Not the perfect reason. The statement given that highest oxidation number in the oxide coincide with group. For example, you get a question like this. Give the oxo anion of manganese in which metal shows oxidation state equal to its group number. Question, write down. Give the oxo anion of manganese in which a metal shows its oxidation state equal to group number. Answer, please. My question for you. Give the oxo anion of manganese in which metal shows highest oxidation state equal to group number. For manganese, answer is MnO4 minus. MnO4 minus is an oxo anion. Oxo means oxygen containing, anion means negatively charged. For manganese, answer will be why? Because in manganese, what's oxidation state of manganese in MnO4 minus? I don't know state of Mn taken to be X fine. Within the compound, state of oxygen is -2. -2 into 4 is -8. X minus 8 equal to -1. X is equal to -1 plus 8 called +7. This is the oxidation state of Mn in MnO4 minus. But this plus state is the highest state of Mn, okay, which is equal to group number. For example, group numbers are starting from 3 to 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Starting from Scooty, Vikraman, Feko, Nikusan. Scooty, Vikraman, Feko, Nikusan. That means in MnO4 minus, it's an oxo anion of manganese. Oxo means oxygen, anion is negative. Having oxidation state is +7, which is equal to group number 7. One more question for you. Give me the oxo anion of chromium in which its oxidation state equal to group number. For chromium, group number is 6. The name of the oxo anion is either CrO4 2 minus or Cr2O7 2 minus. In Cr2O7 2 minus, I don't know, state of chromium taken to be X. Here contain 2 chromiums, so 2X. Within the compound, state of oxygen is -2. -2 is -14 is equal to -2. 2X is equal to -2 plus 14 called 12. X is equal to 6. That means in Cr2O7, it's an oxo anion. Oxygen containing compound having oxidation state 6, which is equal to group number. Or I can say a metal will be showing highest state with a metal, a highest oxidation number of oxides coincide with group number. Fine. That statement is okay, but not the perfect answer. So I can say assertion true, reason true, but not the perfect one. Go with option B. Repeating my question once again. C. A metal shows highest state with oxygen fluorine. Why? Because oxygen fluorine are the most electronegative element, will take maximum number of electrons from metal, and correspondingly the oxidation state of metal increases. Okay. And among oxygen and fluorine, a metal shows highest state with oxygen because oxygen can multiple bond. Because oxygen can make double bond, multiple bond. Fluorine can make only single bond. So reason, but not perfect one. Go with option B. What's that? Okay, I'm relaxing. Farhan, Jaden, Rian, Akshara, Aaron. Continuing. Next one. Before next question, what's that? Before next one, D block elements can show variable oxidation state. Why? D block elements can show variable oxidation state. Why? Why D block elements can show variable oxidation state? Variable oxidation state means more than one oxidation. For example, I can give you manganese. It's a member of D block elements. Can show oxidation state varying from +2, +3, +4, +5, +6, +2 to +7 is possible. It can show variable oxidation state, more than one oxidation state. Why? For example, think about sodium. Atomic number of sodium, or sodium is having atomic number 11, or S block member can show only one state called +1, but D block elements can show more than one oxidation state. Why? Why? Because usually, for example, sodium, atomic number is 11, configuration is 1s2, 2s2, 2p6 and 3s1. Usually for a metal, only valence electron take part in bonding. In case of sodium, valence electron is 1, so one will be take part in bonding. As a result of that, getting an oxidation state of +1. Okay, but in case of D block element, example manganese, atomic number of manganese is 25. Since atomic number of manganese is 25, configuration will be argon. Okay, 4s2, 20, 3d5. Actually, usually valence electron will be take part in bonding. Okay, valence electron is 2, so expected state is +2, but it can show +2, +3, +4, +5. Why? Because their energies are comparable. Since energies of 4s and 3d is comparable, sometimes only 4s electron take part in bonding, getting +2 state. Sometimes only 3d electron take part in bonding, getting +5 state. Sometimes both 4s and 3d electron take part. Because the reason is because of the comparable energies of 4s and 3d, or because of the comparable energies of ns and n-1d orbital. Since energies are comparable, sometimes only D electron take part in bonding, getting a state. Sometimes only S electron take part in bonding, get another state. Sometimes both 4s and 3d electrons take part in bonding. Hope it is fine. But in case of sodium, this energy difference is very high, so only S electron take part in bonding, having a state of +1, because this energy difference is very high. But in case of D block elements, energies are comparable. Since energies are comparable, since energies of Ns and N minus 1d or 4s and 3d is comparable, either d electrons only or sometimes 4s electron only or sometimes boros and 3d electron togetherly take part in bond because of their comparable energies. Okay, so why D block elements can show variable oxidation state? That means manganese can show +2 +3 because of their comparable energies of Ns and N minus 1d. Are you okay? Hope it is clear. Just go for a 2 minutes or 1 minute break. We'll join back soon. There's a technical issue. We'll come back soon. Just 1 minute. Hold on, please. So now the video is improved, I guess, right? So there was some glitch over there. It's fine now. Can I start? What do you feel? Jaden, Farhan, Hamdan. Now the glitching is gone, I guess, right? Can I start? Now the glitch is gone, I guess. Okay, fine, continuing. So we started over why D block elements can show variable oxidation because the comparable energies of Ns and N minus 1d, sometimes only Ns electron take part in bonding, sometimes only N minus 1b, sometimes both will take part. Okay. Now my question for you, why D block elements can form complexes? Why D block elements can form complexes? Why D block elements can act as catalyst? Why D block elements can form colored compounds? Why D block elements can form colored compounds? Okay, first one, why D block elements act as complexes? Example, you can see complex such as K4, FeCN6. Metal is Fe coming from D block. Why D block elements can form complex? Or PT, NH3 twice Cl2. Metal is PT, again coming from D block. One more example, CO, NH3 6 times Cl3. Metal is cobalt, again coming from D block. Why D block elements can form? Majority of the complexes are formed by D block elements or metals are coming from D block. Why K4, FeCN6, metal is Fe, D block element. PT, NH3 twice Cl2, PT, platinum, again coming from metal, D block elements. Or CO, NH3 6 times Cl3, cobalt, metal coming from D block element. Why? Because of their availability of vacant d orbital. Because of the availability of vacant d orbital, they can make coordinate bond with the metal or they can make coordinate bond with the ligand. Second one, you can say because of their small size and high charge density. Because of their small size and high charge density. Because of their small size and high charge density. Okay. So majority of the complexes are formed by D block elements. Why? K4 FeCN is Fe D block. Coming from tungsten elements. Why? PT, NH3 twice Cl2, PT is metal coming from D block elements. Why? CO, NH3 thrice Cl3, cobalt is metal coming from D block. And most of the complexes are formed by D block elements. Why? Because of their vacant d orbital, they can make coordinate bond with the metal, or you can say because of their small size and high charge density. Okay. Next one. Why D block elements can form catalyst? Because, for example, I can say ammonia prepared by Haber process, catalyst is platinum coming from D block. sulfuric acid prepared by contact process. Catalyst is vanadium pentoxide, vanadium coming from D block. I mean, most of the catalysts are coming from D block elements. Why? Ammonia prepared from Haber process, catalyst is platinum. Why? I mean, why D block elements can act as catalyst? H2SO4 called sulfuric acid prepared by contact process, catalyst is vanadium pentoxide. Again, vanadium coming from D block elements. Why? Or most of the D block elements can form catalyst. Why? Reason 3. First one, because of their variable oxidation state. Because of their variable oxidation state, they can form intermediate complexes. Or one more reason, because of their ability to form complex also help in their catalytic activity. Ammonia prepared by Haber process, catalyst platinum coming from D block. Why? H2SO4 contact process, vanadium pentoxide, catalyst vanadium coming from D block elements. Why? Or most of the D block elements can form catalyst. By reason, because of their variable oxidation state in which they will be forming intermediate complexes to form product. Second one, we can say because of their large surface area where reactant molecule combined to form product, or their ability to form complex. Their ability to form complex also help them. Ability to form complex also help them to act as a catalyst. Also help them act as a catalyst. Okay, next one. D block elements are colored. Why? Why D block elements are colored? Actually, you may study in lab that said lab that flame coloration test. When you give flame, each one showing its own color. Why? Lithium shows crimson red, sodium shows golden yellow, potassium violet. Why they show color? Because if you give energy or heat, it's called a flame coloration test. If you give heat, or it's a form of energy, by using energy, electrons will be excited from lower state to higher state, but higher state will be unstable, come back to lower. If they move from lower to higher, will be absorbing energy. If they move from higher to lower, will be emitting energy, which can be seen as visible light. So why D block elements are colored? Before that, why S block elements can show flame coloration? Flame means when you give flame or heat, each one will show its own color. Lithium shows crimson red, sodium shows golden yellow, potassium shows. Why? Because you are giving flame or heat is a form of energy. By using energy, electron will be excited from lower state to higher state will be unstable, come back to lower. If they move from lower to higher, will be absorbing energy. If they move from higher to lower, emitting, which can be seen as visible light. Example. But that is actually S block. But here, why D block elements are colored in aqueous medium? In aqueous medium can be explained by using CFT. In aqueous medium, in presence of water ligand, during the formation of the complex, 5d orbital split into two sets of d orbital, having lower energy and higher energy. Any electrons in the lower d orbital, if they get energy, will be excited to higher state, but higher state is unstable, so come back to lower. If they move from lower to higher, they will be absorbing energy. If they move from higher to lower, they will be emitting, which can be seen as visible light. Simply, you can say because of dd electron transition. You can say because of dd electron transition. During the formation of complex, or in aqueous medium, in presence of water, during the CFT or crystal field complex, you can say D block will be split in two sets of d orbital having lower and higher energy. Any electrons in the lower d orbital, if they get energy, will be excited to higher state, but higher state is unstable, come back to lower. If they move from lower to higher, they will be absorbing energy. If they move from higher to lower, they will be emitting energy, which can be seen as visible light, simply because of dd electron transition. Or I can say, if the configuration is D0, D10, they will be colorless. Why? D0 means no d electron to excite. D10 means there is no space to it because completely occupied. So if configuration is D0, D10, they will be colorless. So I'm started from here. Why D block elements can show variable oxidation state? Because of their comparable energies of Ns and N-1d. Common oxidation state of 3d series is +2. Common oxidation state of 3d series is +2, but zinc shows only +2. Why? But zinc shows only +2. Why? Because atomic number of zinc is 30, having configuration argon 18, 4s2 20, 3d 10. D block elements can show variable state because of the comparable energies of ns and n-1d. Okay. Common state of 3D series is +2, but zinc shows only +2 because in Zn 2 plus. After removing 2 electron, it will get a 3D10 fully filled stable configuration. Scandium shows, even though common state is +2, scandium shows +3. Why? Because in scandium, atomic number is 21. 21 means configuration will be argon 18, 4s2 20, 3d1. C3 plus means 3 electrons are gone. 3 will be gone from 2 from 4s, 1 from 3d. Remaining will be getting stable noble gas configuration argon. So why D block elements can show variable state? Because of the comparable energy. Common state of 3D series is +2. Zinc shows only +2 because +2 is 3D10 stable configuration. But scandium shows +3 because in +3 having stable, noble gas configuration. Okay. Why D block elements are complexes, or majority of the metal in the complex are coming from D block elements. Why? Because of their vacant D, or they can make a coordinate bond with metal. Because of their small size and high charge density. Why D block elements can form catalyst, ammonia, platinum coming from D block. H2SO4, vanadium coming from D block because of their variable oxidation state, because of their large surface area where reactant molecule combined to form product, or ability to form complex also help them act like a catalyst. Why D block elements are colored? Due to D electron transition. But remember, D0, D10 will be colorless. Any electrons in D orbital get energy will be excited to higher orbital. It will be unstable, come back to lower. When they move from lower to higher, will be absorbing energy. From higher to lower will be emitting, which can be seen as visible light or color. But remember, D0, D10 will be colorless. Okay. Why D block elements can form alloys? Why D block elements can form alloys? What are alloys? Alloys are mixtures of metal. It's like brass, bronze, copper, zinc, copper, tin. Since their sizes are almost similar, you can easily replace one atom by other. Copper can be replaced by zinc. Since sizes are almost similar, we can easily replace one atom by other. That's why D block elements can form alloys. What are alloys? Alloys are mixtures of metal, brass, bronze, German silver, etc. Anyway, I can say you, like, in case of alloys, in case of why D block elements form this much number of alloys, because sizes are almost similar. Since sizes are almost similar, one metal can easily replace by other. That's why they can form mixture. That's why they are called as alloys. Okay. Why D block elements can form interstitial compounds? Why D block elements can form interstitial compound? What is meant by interstitial compound? Platinum, palladium, etc. are heavier elements of D block. Platinum, palladium, etc. are heavier elements of D block. If these elements are formed, there will be having so many vacant space, there will be having so many void which is occupied by smaller atoms called hydrogen, carbon, nitrogen, etc. This is called these spaces occupied by, or I can say platinum, palladium are heavier metals of D block. If these elements are formed, there will be having so small gap, void or interstitial site occupied by smaller atoms called hydrogen, carbon, nitrogen. Such compounds are called interstitial compound. These interstitial compounds are more harder than normal metal. Since it's more harder, it will be having high melting point. It will be having high melting point. But remember, it will be less malleable. It will be less malleable. It will be less ductile. It will be less ductile, and it will be less reactive too. It will be less reactive too. And most of the interstitial compounds are non-stoichiometric. Why? What is meant by non-stoichiometric? Example, lanthanum forms an interstitial compound called LaH 2.87, where our vanadium forms an interstitial compound called VH.5. After their formation, their stoichiometry is not a correct whole number like NH3, H2O, CO2. That's why they are called as non-stoichiometry. So what is meant by interstitial complexes or interstitial compound means platinum, palladium, etc. are heavier elements of D block. These elements are formed, there will be having so many vacant spaces, interstitial sites or void occupied by smaller atoms called hydrogen, carbon, nitrogen. Will be that such compounds will be more harder, will be having more melting point, but they will be less malleable, less ductile, less reactive, and they are non-stoichiometry. Non-stoichiometric means after the formation of complex, their numbers are not an whole number like NH3, H2, or getting a fraction called LH 2.87 or VH 0.56 and all. So things are fine, I guess. So why they are forming alloys? Because sizes are similar. We can easily replace one by another. Why they are forming interstitial compounds? Because reasons, these features of interstitial compounds are very important. They are more harder, so we'll be having high melting point, but less malleable, less ductile, less reactive, and they are non-stoichiometric. Okay. So my question, what was the question actually? Okay, come back to my question. Which of the following element does not show variable state? Please, fast. It's almost time up. Come fast, please. Why D block elements, or which of the following element does not show variable oxidation state? Answer is zinc, because zinc shows only +2. Zinc shows only +2. Atomic number of zinc is 30. Since atomic number of zinc is 30, configuration will be argon 4s2 3d10. Zn2+ means 2 electrons are gone. 2 will be gone from 4s. Remaining will be 3d10. So the one showing only positive oxidations, or one shows does not show variable oxidation state, will be zinc. No doubt, sure, clear, right? Go with option C, please. Next one. The catalytic activity of transition metal and their compound is mainly due to variable oxidation state, provided large surface or ability to form complex. Why D block elements can act as catalyst? Will provide because of their variable oxidation state, provided large surface or their ability to form complex. So I can say ability to exhibit variable state, option C. Now, which of the following statements about interstitial compound is incorrect? They are chemically reactive. Wrong. Because interstitial compounds will become much harder. So we'll be having high melting point, but will become less malleable, less ductile, less malleable, less ductile, less reactive, and they are non-stoichiometric. So they become chemically reactive is wrong statement. I need the wrong one. Go with option A, please. That's it. Now, just I'm concluding my session right now. We'll get a question like this. 3D series starting from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, Scooty, Vikram, and Feko. The one shows +2 state is zinc. One shows +3 state is scandium. One shows maximum number of oxidation state is manganese. Highest melting point is chromium, highest enthalpy of atomization is chromium, lowest melting point is zinc, and lowest enthalpy of atomization will be zinc. The one which shows positive electrode potential will be copper. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, Scooty, Vikram, and Feko. One shows +2 state only zinc. One shows +3 state is scandium. One which has highest melting point, highest enthalpy atomization is chromium, because melting point or enthalpy of atom depends upon metallic, which depends upon number of unpaired. Why someone is having high melting point? Because more number of unpaired, so more metallic bonding, more melting point. Why someone is having less melting point? Because number of unpaired less, metallic bonding is less, so melting point is less. Why someone is having high enthalpy atomization? Depends upon number of unpaired. If number of unpaired is more, metallic bonding will be more, enthalpy of atomization will be high. Concluding, among the 3D series, highest melting point chromium, highest enthalpy atomization chromium, lowest melting point is zinc, lowest enthalpy atomization zinc. One shows only +2 is zinc. One shows +3 is scandium. One shows positive electrode potential is E0 value positive is copper. One shows highest number of oxidation state is manganese. I'm winding up my session right now. Actually, I left with few more questions, but we can do it later. My session started from lanthanoid contraction. Lanthanoid contraction means slow, steady decrease in atomic size as we move from lanthanum to lutetium due to poor shielding of F subshell. When shielding effect is less, size will be less. Hope it is clear. My second question was, Cu plus is unstable because it undergo disproportionation to become Cu2 plus. Cu2 plus means charge is increasing, size is decreasing, hydration enthalpy is increasing, stability is increasing. More energy liberating means more stability. Then I moved into E0 value. Negative means undergoes oxidation, so hydration enthalpy greater than sublimation enthalpy plus ionization. Positive is reduction, so hydration enthalpy lesser than sublimation plus ionization. We moved into acidified. This is my key point for you. Travel agent will not be traveling. He will be helps for traveling. So oxidizing agent helps in he will not undergo oxidation under reduction to become Fe2 plus 2 Fe3 plus Sn2 plus 2 Sn4 plus I minus 2I2 H2S twice. Fe2 plus become Fe3 plus means oxidation state of iron is increasing. Increasing state is called as oxidation. Take place with the help of oxidizing agent, which is Cr2. He will not undergo oxidation. He will under reduction to become a Cr3 plus byproduct is water. Now mish metal is 95% of lanthanoid metal and will be having 5% of iron and will be having traces of small elements called carbon, calcium, sulfur, silicon and aluminum can be used as a flint. Yes, oh, sorry, yeah, 95 lanthanoid, right? Yes, 95% of lanthanoid metal. Option C, oh, sure. Option C, sure. Sure, right? 95% of flint one, right? It is option C. Now, my next question was, metal will be showing high state with oxygen full because they are most electronegative, but a metal will be showing high state with fluorine, not fluorine because with oxygen, because oxygen can form multiple bond. Then variable oxidations because of comparable energy. Then complex, reason given, catalyst okay, colored okay. Then alloys because of similar size. Interstitial complex are more harder, more melting point, less malleable, less ductile, less reactive, but they are not stoichiometric. Now it is okay. But my prediction for you, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. One showing +2 state is zinc, +3 state is scandium, highest melting point chromium, highest enthalpy atomization chromium, lowest melting point zinc, lowest enthalpy zinc, and the one shows positive electron potential is copper. That's all. Bye. I think I moved a little bit more. Thank you. You can join. I will join for you the chapter. Aldehyde ketone. Get ready, please. Bye. Dia, Christopher, Asher, Ibnet. Bye. Thank you. It's okay. Take a break.
Yes, good evening students. So we are a bit late today. Anyway, we'll start with the aldehydes, ketones and carboxylic acids. All of you can hear me, right? Yes, so we are going to start aldehydes, ketones and carboxylic acids. For the board exam, this chapter has weightage of 7 marks. There are word problems, there are conversions. It's a big chapter. The content wise it is larger. So we'll try to make around few points of this chapter which is really important for the board exam that we are going to discuss today. Okay, so you may get around 3-4 marks or even 5 to 6 marks from this topic here. All important sessions we will discuss here. Just wait, we are going to start. So first question, all of you can hear me, right? Yes, okay. So we are starting the session now. We will go for first one, preparation of aldehydes and ketones, chemical properties. Then we will discuss carboxylic acids, then chemical properties of carboxylic acids. We will follow the same order as in the reader. Okay, so be ready. First one, the product obtained in the following reaction, C6H5COCl plus CdCH2CH3 twice is dash. This is one of the method of preparing aldehyde as well as ketone from acid chloride. Acid chloride you can prepare aldehyde also, you can prepare ketone also. I'm just telling briefly the idea, right? Yes, listen. So we can say this is equal to acid chloride. We can say R C double bond of Cl. This is acid chloride. Now this acid chloride, if I am treating it with the hydrogen bar palladium and barium sulfate, okay, hydrogen bar palladium, barium sulfate, what you will get? So easy, you will replace this chlorine by hydrogen. You will get RC double bond of H. This is an aldehyde. You will get aldehyde, right? This is aldehyde. Okay. So acid chloride on treating it with the hydrogen bar palladium in presence of barium sulfate, you will get aldehyde. Just replace this chlorine, put hydrogen. Remove chlorine using screwdriver, fit hydrogen over there. Okay, you will get aldehyde. Now how to get ketone? Now see. Yes, we are treating it with the dialkyl cadmium. We can say R twice CD. This is called dialkyl cadmium. When you are treating with the dialkyl cadmium, don't think much. Very simple logic. Remove chlorine, put R. Here R is sitting laughing at you here. R is here inside the bracket. Just remove chlorine, put R over there. Okay, so you will get which one? Tell me. Yes, RC double bond R. Now some of them have confusion. Sir, this R and this R may be same or different. No matter, this R and this R may be same or different. No issue at all. So you will get ketone. This is the method. Anybody can tell me what's the name of this reaction? Say fast. What's the name of this reaction? Tell me fast. Yes, very good. So this is called what? Tell me. Rosenman reduction. This reaction is equal to Rosenman reduction. Study student, this concept is very important for the board exam. You can see so many questions are coming from this area. Now can you tell me the answer? What's the answer here? Yes, tell me the answer. The product obtained in the following reaction. Now they are not giving in the form of structure. If it is structure, it will be easy. Let us discuss this answer here. Okay, wait. So C6H5, we can say C6H5 COCl. Treating it with a CH3 CH2 twice CD, right? Twice CD. What's the answer here? Very simple. You can replace this chlorine by alkyl group here. Which is the alkyl group here? The alkyl group over here, it is CH3, CH2. Just remove chlorine, replace it by alkyl group. What's the answer? Yes, you will get the answer as, so you will get the answer as C6H5 CO CH2 CH3. Now the question is, what's the name of this compound? This is little more tough because they are not giving the structure, they are giving the IUPAC name. Anybody can tell me what's the answer here? Anybody? Tell me fast. Yes, we can say C6H5 COCH2 CH3. We can say this is equal to number 1, this is number 2, number 3, because this can be written as benzene ring with the C double bond O, CH2, CH3, right? A UPSC name. We can see the weightage is more for this ketonic group. So we will start numbering. We will start numbering from the side where major priority functional group is here. This is the numbering. So we will start numbering from here. 1, 2, 3. The name of the compound is 1-phenyl propan 1-non. So the answer is 1-phenyl propan 1-non. Okay. So the answer is B. Okay. All of you got it? So learn this part. This is an important area for the board exam. You may get 1 mark from this area. It's very, very important. Learn it. So we are moving to the next question. All of you got it, right? Yes, sure. Shall I move to next question, right? Okay, very good. So we are moving to the next question now. Okay. Yes. The next question we are talking. The product obtained in the following reaction. This is a CBSE reader topic. We know this one well. Can you tell me what is this product? Anybody can tell me the answer. It's easy. It's a direct question. Yes. Do you remember about Stephen reaction? Yes, we are going to do. This is the content I am explaining now. Listen here. Yes, this is equal to RCN, RC triple bond N. What we are doing? We are doing reduction. Reduction with the hydrogen in presence of, SnCl2 and HCl. Actually, in the reader, they are giving SnCl2 and HCl. Okay, SnCl2 and HCl. Yes, SnCl2 plus HCl. Yes, reader, they are not giving any hydrogen. Actually, it is SnCl2 and HCl. Okay, SnCl2 and HCl will provide hydrogen. They will react each other to provide hydrogen. Now, what happened to hydrogen? Yes, hydrogen atom get added over here. Hydrogen will be supplied by this reactant, and hydrogen get added to carbon, and hydrogen get added to nitrogen. In the first step, you will get a compound like that, RCH double bond NH. This is a compound. This is an intermediate. Okay. So this is an intermediate generated. Now we will do hydrolysis. What is hydrolysis? Yes, hydrolysis is nothing but H3O plus, thing like that. Water in presence of acid, that is hydrolysis in presence of acidic medium. You will get RCHO plus NH3. This is the answer. Now coming back to this question. See, this question so easy now. They are not giving in 2 steps. They are giving all together in single step. This reaction, we know this reaction is coming under Stephen reaction. Now we are coming back to this question, right? Anybody can tell me the answer? Very simple. So nitrile on treating it with SnCl2 and HCl followed by hydrolysis. We are doing this one together. We are doing these 2 steps together. So easy. This is the steps you can say RCN. Number 1, SnCl2 and HCl. And number 2, H3O plus. You can directly write RCHO. Don't think much. Nitrile with SnCl2 and HCl and H3O plus. You will get aldehyde. So the answer is this one. B. Answer is B, right? So the answer is B. So this answer for this particular question is B. So easy question. I think all of you got it, right? So we are moving to the next question. Is it okay? Yes, respond fast. Are you okay with it, right? Very good. So we are moving to the next question now. Okay, yes. So we can say this question also very important for the exam point of view. It came before in the exam. Here, this is a bit harder for some students. Some students are struggling with this topic. So we will do what is this? Okay. We studied preparation of aldehyde by side chain chlorination of toluene. We studied this one. Here a lot of confusion is there for this particular topic. What is the answer? There are so many possibilities here. Okay. So now what is the structure of A they are asking? See, anybody can tell me what's the answer? I want the answer from your side. Tell me fast. Yes. I want to know how many of you know this. Anybody? Okay, answer is A. No, that's not the answer. Think properly. Okay, I will discuss here. Okay, that's why this is a bit harder for some students. We will discuss. Okay, wait here. Listen. So, first one, I have toluene here. Yes, I have toluene. This is Mr. Toluene, right? CH3 here. Now, I'm doing side chain chlorination. We know side chain chlorination, you will get a license to remove hydrogen and keep chlorine there. Very simple. you will get a license to remove one of the hydrogen from here, replace it by chlorine. Okay, so I'm doing chlorination with 1 mole of chlorine, with 1 molecule of chlorine. I'm doing chlorination with 1 molecule of chlorine. Yes, what I will get? I will get benzene ring with the CH2Cl. This is a compound I got. Okay, 1 molecule of chlorine, you will get CH2Cl. Then 2 molecules of chlorine. You have 2 molecules of chlorine. Think like that, 2 moles of chlorine. So 2 hydrogen atom replaced by 2 hydrogen atom is replaced by chlorine. You will get a compound like that. Benzene ring with the CH2. We can say benzene ring with the CHCl. Okay, benzene ring with the CHCl. This is a compound. If you have 3 moles of chlorine, we can say 3 moles of chlorine. Yes, if you have 3 moles of chlorine, you will get benzene ring with the CCl3. These are the different products obtained. This one you studied in first chapter, means toluene, side chain chlorination, monochlorination, you will get this one, dichlorination, you will get this one, trichlorination, you will get this one. Okay, now coming back to this particular question, now followed by hydrolysis. See, this is very highly reactive towards nucleophilic substitution reaction. We know that this compound is highly reactive towards nucleophilic substitution reaction because this is benzylic halide. We know that benzylic halides are highly reactive towards nucleophilic substitution because it has more stable carbocation. So benzylic halide has more stable carbocation. It is more reactive towards nucleophilic substitution reaction. So whenever it reacts with water here, whenever it is reacting with water here, what is the answer here? You can say whenever it reacts with water, we can say on reacting with water, you will get benzyl alcohol. Here you will get benzyl alcohol, CH2OH, right? Whenever it reacts with water here, you will get, you can say whenever it reacts with water, whenever it is reacting with water, yes, you will get, you can see CHOH. This is the answer. Okay. Now this will be converted into benzaldehyde. Here water is removed. Water is removed. After removing water, you will get benzaldehyde here. Okay. You will get benzaldehyde. This is the answer. These 2 portions are there in the CBSE syllabus. First one is also there. Second one is there. Third one is not there in the syllabus. Third one, if you want, I can tell, on treating it with water, all 3 chlorine will be replaced by OH, and finally you will get benzoic acid. This you will get benzoic acid. Okay, this is a different compound obtained by hydrolysis. Now can you tell me what is the answer here? Anybody can tell me the answer. Now check the chart and tell me the answer. Note down the chart. It's very important. Note down. Tell me what is the answer. Tell me the answer first. Yes, option is B. This is your answer. If it is CH2OH, what will be the answer? Tell me. If final product is CH2OH, the answer will be what? B, right? Like that. If final product is benzoic acid, that you can expect for the NEET exam or JEE exam. If final product is benzoic acid, then what will be the answer? The answer will be CCl3. Got it? Note down. This is very important. Note it down. Yes. Got it? Yes. So we are moving to the next question. I hope all of you got it, right? Put this one in brain. It's very important. Go through it. The next one we are talking. Okay. Yes. Next one we are discussing now. Yes. So this is toluene here. Toluene on treating with the chromyl chloride and in presence of CS2 followed by hydrolysis. You are getting benzaldehyde. It's a direct reaction. Anybody can tell me what's the answer here? Anybody? I want the answer. It's a direct reaction. Tell me. Yes. Rasal, tell me. Anybody? Hiba? Yes. Very direct reaction. The answer is what? Tell me. Ittard reaction. The answer is Ittard reaction. Direct reaction. This is coming in the exam. Go back and study. I'm not explaining much. You are familiar with this toluene on treating it with the CrO2, Cl2, CS2, H3O plus. You will get benzaldehyde. Do you want explanation? Tell me. Accordingly, I can do it. You know, there is an intermediate generated in Ittard reaction that also you have to read it. It is there. If you want, I can explain. See now, this is equal to, you can say, Yes, this is equal to, we can say, toluene. Toluene is here. This is toluene. Now, we are treating it with the initial step is that CrO2Cl2. CrO2Cl2 in presence of CS2. CrO2Cl2 we call it as chromyl chloride. Yes, CrO2Cl2 is called chromyl chloride. It's an oxidizing agent. So, it is insoluble. Actually, this compound is insoluble in water, so we are using carbon disulfide as a solvent. Carbon disulfide is a solvent. Chromyl chloride is the oxidizing agent. So CH3, toluene get oxidized to form benzaldehyde. But intermediate is required. The intermediate generated is like that. This is the intermediate. You can write CH here inside the bracket. CH only I wrote. Out of the CH3, I wrote only CH. Inside the bracket, I can write the remaining thing. Yes, I am writing the remaining thing. Inside the bracket, remaining hydrogen we are writing H, then twice. So it is nothing but CH3, nothing but CH3C. CH3 here, CH3 here, CH and H2 over. Repeating, CH3 here, CH and H2, CH3. Now we are writing the intermediate. What is the intermediate? See, you can write this one, this compound, entire compound, that is OCrOCl2. OCrOCl2. OCrOCl2 is nothing but CrO2Cl2. Repeating, OCrOCl2 is nothing but CrO2Cl2. This is the intermediate generated. This intermediate upon hydrolysis, you can say, upon hydrolysis, say H3O plus, you will get benzaldehyde. Okay. This is the method of conversion of toluene to benzaldehyde. The reaction is called Ittard reaction. Okay, got it. So learn this. This is one of the important area. When a body is targeting this area, just go through it. Sometimes they may ask, what's the structure of intermediate? So you must study the structure of intermediate also. This is very, very important. Okay, go and study. So we are moving to the next question. This is a direct question. Not much tough. You have to study this intermediate. That's it. Intermediate structure. Beware of this one. It is coming. Sometimes there is a chance. Objective question, they may give A as an intermediate and they can ask. Okay. Next one we are talking assertion. So we know the chemical properties of aldehydes and ketones. I am talking about chemical properties. Preparation area, somewhat we covered. Now, which are the chemical properties? So we know that important chemical properties of aldehydes and ketones are coming under, actually it is nucleophilic addition reaction. Aldehydes and ketones undergo nucleophilic addition reaction. Out of aldehyde and ketone, you know that which is more reactive. What is nucleophilic addition reaction? Yes, just briefly I am telling. What is nucleophilic addition reaction? This is equal to aldehyde. Okay, this is aldehyde. C double bond O H. Right? Now we are adding nucleophile, a reagent which can produce nucleophile. For example, I am writing HCl, right? HCl. HCl will generate H plus and Cn minus. H plus and Cn minus, which is a nucleophile here. Simple, Cn minus is a nucleophile. And now, nucleophile prefer positively charged carbon atom. Suppose I am conducting an interview with a nucleophile. I am asking, whom do you like the most? Immediately, nucleophile will say, yeah, I like positive charged carbon. The nucleophile will be behind the positively charged carbon, without any doubt. See, listen. Now, Cn minus is coming and attacking the carbon. Why? Because this carbon atom has some sort of positive charge and this oxygen has some sort of negative charge. So the nucleophile will attack here and H plus get added here, nucleophile get added here. You will get the final product. The final product is after nucleophilic addition, you will get a product here, RCH, then you can say OH, then Cn. This is the answer. The final product over here is called cyanohydrin. This is called cyanohydrin. Aldehyde or ketone will undergo nucleophilic addition with HCl to produce cyanohydrin. And now, which is more reactive towards nucleophilic addition reaction? Aldehyde is more reactive. See, this is aldehyde. If I am talking about ketone, how it will be? Yes, ketone you can see, this is ketone, R, C, double bond O, R. In ketone, you can see there is one bulky group here. there is another bulky group here. Okay, in aldehyde there is one bulky group, there is one small tiny group here. It's just like a small security, small kid only. This is just like a big security. These are two big securities are there. Now when nucleophile is attacking the carbon, it will not attack like this. In the mechanism we already studied. So nucleophile is attacking from behind. Nucleophile is attacking from behind. Here also nucleophile is attacking the carbon atom from behind. During the attack, the nucleophiles experience a repulsion from the existing group. These groups are there, they will repel the incoming nucleophile. When they are repelling incoming nucleophile, the reactivity of nucleophilic addition is inversely proportional to the steric effect. The repulsion experienced here is equal to steric effect. The repulsion experienced here, we call it a steric effect. Here also, repulsion experienced here, we call it a steric effect. That will be more for ketone because two bulky groups are there. That will be less for aldehyde because, less bulky groups are there. So steric effect is less for aldehyde. When steric effect decreases, reactivity increases. So aldehydes are more reactive. Number one reason, because of less steric effect. This is one reason why aldehydes are more reactive towards nucleophilic addition reaction. Now second reason, what is second reason? See, as I told you before, nucleophile likes positively charged carbon. Wherever positive charged carbon is here, nucleophile go and attack there. So now, in front of this nucleophile, if I am keeping aldehyde and ketone, nucleophile will select whom? That's an important thing. Nucleophile will select aldehyde. Second reason here, aldehyde carbon atom. See, this is the aldehyde carbon, carbonyl carbon. This is called carbonyl carbon. This is the carbonyl carbon atom of ketone. Ketone has same polarity over there. Ketone has positive here, negative here. But positive charge of carbon atom in aldehyde. See, positive charge of carbon atom in aldehyde is comparatively more than that of ketone. Repeating, positive charge of carbon atom of aldehyde is comparatively more than that of ketone because of less number of electron donating groups. Here you have alkyl groups. Alkyl groups are electron donating. These alkyl groups are pumping the electron here, pumping the electron. So this positive charge will be minimized by donation of electron from alkyl group. So here donation is coming only from one side, donation from other side is not there. So this carbon atom will have less positive charge, this carbon atom has more positive charge, and nucleophile will prefer to attack this carbon. So second reason why aldehydes are more reactive than ketones, the reason is that we can say more electron deficient carbon, or more polar carbonyl carbon. That's the second reason. Second reason is that more polar carbonyl carbon, more electron deficient carbonyl carbon. Okay, more polar. Aldehydes are more polar, or you can say aldehyde carbon atom is experiencing more electron deficiency compared to ketone. Now can you tell me the answer now? What's the answer here? Can you read the question now? Reactivity of ketone is more than aldehyde. What is the reason? Reason, the carbonyl carbon atom of ketone is less electrophilic compared to aldehyde. Assertion is correct, no doubt. Assertion is correct. See students, assertion is correct without any doubt. Assertion correct. What about the reason? Yes, carbonyl carbon atom of ketone is less electrophilic. Less electrophilic means less positive charge. Carbonyl carbon atom of ketone is less electrophilic, indicates it has less positive charge compared to aldehyde. Yes, correct. So now what is the answer here? Here assertion is correct, reason is correct. This is one of the reason for less reactivity of ketone, because carbonyl carbon atom of ketone has less positive charge, or less electrophilic, or less polar. So that's the reason we can say both assertion, reason correct. Reason is the correct explanation. Okay, this is very important area. This area every time they are asking one question, order of reactivity of nucleophilic addition, a reaction of aldehydes and ketones. Every time they are asking, very, very important. Completed students? All of you completed? Assertion is right, reason is right, correct explanation. Okay, so we are moving to the next question. Yes, listen. Now we are discussing more. Okay, students, listen. Which of the following is more reactive towards nucleophilic addition reaction? Just now we studied what is the order of reactivity of aldehydes and ketones towards nucleophilic addition. The order of reactivity you can note down if you want. Order of reactivity is like that. Aldehyde is smaller, aldehyde is more reactive. Smaller aldehyde is more reactive. Then bigger aldehyde, then normal aldehyde, then aldehyde. Then we can say ketone. Then we can say bigger ketone. Bigger ketone. Okay, this is the order of reactivity towards nucleophilic addition. Repeating it again. What is the order of reactivity? We can say first one, smaller aldehyde. Smaller aldehyde will be more reactive towards nucleophilic addition. Second one, normal aldehyde, bigger aldehyde. Third one, ketone. Provided ketone and aldehyde must contain same carbon. Ketone and aldehyde must contain same carbon. Okay, so that's the thing. Then we can look for the answer. This is the order of reactivity towards nucleophilic addition reaction. Reactivity towards nucleophilic addition reaction. Okay, nucleophilic addition reaction. Reactivity towards nucleophilic addition reaction. Okay, nucleophilic addition reaction. Note down, this will be useful for you. So smaller aldehyde is more reactive, then aldehyde, then ketone with the same number carbon, then bigger ketone. Can you tell me the answer now? This is so easy for you now. After learning this will be so easy for you. Anybody can tell me the answer? Which is your option correct? Which of the following is most reactive in nucleophilic addition reaction? Tell me. Yes, I want a response from your side. What is the answer? Yes, students? Yes, the answer is what? Tell me. A, right? So HCHO is the most reactive towards nucleophilic addition reaction. Remember, HCHO is the most reactive towards nucleophilic addition reaction. So we are moving to the next question, right? Listen. Yes, complete it fast. Next one. Okay. Listen. So the product formed in the reaction. The product formed in the reaction. What is the answer here? So we can say benzene ring with the C double bond O, COOC2H5, NaBH4. What is the answer? Listen. So this is a reduction as well as reduction of aldehydes and ketones. We know that reduction of aldehydes and ketones we studied. So what is a special reduction and normal reduction? Yes, listen. Normal reduction, we are doing this answer. Here C double bond O, benzene ring with the COOC2H5 is there. So listen, okay. Yes, we are talking now. Here, this particular question, what is the answer here? This particular question we are talking, this is a compound. We have a compound here. This is double bond O, double bond O. This is COO, C2H5, COO, C2H5, right? C2H5. Remember. So, C double bond O, C2H5, NaBH4, NaBH4. We study, students, this one in CBSE. Yes, we studied. What's the answer? Anybody can tell me the answer here? Tell me fast. See, students, can you tell me the answer fast? Yes, what's the answer here? Tell me. Yes, we can say C double bond O, COOC2H5 on treating it with NaBH4. Okay, what's the answer? Listen. C double bond O, COOC2H5 is here. So this is equal to ketone. This is ketone. NaBH4 can reduce ester. NaBH4 cannot reduce ester. NaBH4 can reduce what? Ketone. So the answer we study like that. This is equal to ketone or C double bond O R. On treating it with NaBH4 or H2 bar Ni, or you can say LiAlH4, you can convert this one into what? Tell me. RCHOH. we can say RCHOHR. Okay, this is the reaction, RCHOHR. So RC double bond R on treating with NaBH4 LaOH4, you will get RCHOHR. That is ketone upon reduction, you will get secondary alcohol. So now this is ester. This is ester. We can say this ester can be written as ester structure will be C double bond O C2H5, right? Ester structure will be C double bond O C2H5. So NaBH4 cannot reduce ester. Remember, NaBH4 cannot reduce ester. Okay, that's it. NaBH4 cannot reduce ester. So here answer will be like that. Ester will be intact over there. NaBH4 cannot reduce ester. NaBH4 can reduce only ketone. Ketone will be converted into secondary alcohol. So the answer here, it will be like that. Yes, cyclohexane ring over here. This will become OH over here. Ester is no difference in ester because NaBH4 cannot reduce ester. So the answer will be, which one? Tell me the answer. Yes, option A will be the answer, right? Option A will be the answer. This is your answer because so the ketone get reduced to secondary alcohol and then ester will retain there. NaBH4 cannot reduce ester. So the answer is A, right? All of you got it, right? Yes, very good. So we are moving to the next question, right? Yes, listen. So the next question we are talking. Listen. Phenyl methyl ketone can be converted into ethyl benzene in one step by which of the following reagents? So let me do this one. Wait. Okay. Listen now. Yes, listen. See now. So this is normally, this is aldehyde, R, C double bond O, R, ketone. This is, we can say R, C double bond O, H, aldehyde. I am treating it with a zinc amalgam and HCl. Zinc amalgam and HCl, right? Okay. Or I can use another reagent. I can say another reagent. I can tell. Yes. Another reagent is hydrazine, NH2, NH2, KOH and glycol. Okay. NH2, NH2, KOH and glycol. Very simple now, students. You will get a license to remove this oxygen and put hydrogen. You will get license to remove oxygen, put hydrogen. You will get RCH2. R. You will get a hydrocarbon. Okay. Here also you will get the same answer, NH2, NH2, KOH and glycol. You will get an intermediate and final product will be RCH2R. This is a reagent used to convert aldehyde or ketone into corresponding hydrocarbon. If it is aldehyde, what is the answer? Yes. Suppose you have an aldehyde under the same reagent. Out of this anyone, this C double bond O become CH2. You will get R CH2H, CH2H. C double bond O become CH2, then H, that is nothing but RCH3. So you can convert aldehyde or ketone into corresponding hydrocarbon by using reduction with zinc amalgam and HCl as well as NH2, NH2, KOH and glycol. Anybody can tell me what's the name of this reaction? Anybody tell me fast. This reaction is equal to, you can say, Clemmensen reduction. This is equal to Clemmensen reduction. This is equal to Clemmensen reduction and this one is equal to Wolff-Kishner reduction. Okay, Wolff-Kishner reduction. This content you have to study. This is one of the important topic. So ketone upon reduction with the zinc amalgam and HCl or NH2, NH2, KOH and glycol, you will get RCH2R or you will get RCH hydrocarbon. Aldehyde also, here in this case C double bond O is converted into what? CH2. Here also C double bond O is converted into what? CH2. Since hydrogen is there, that CH2 become CH3. That's it. Okay. So coming back to this question, anybody can tell me the answer now fast? Anybody can tell? Phenyl methyl ketone. Now the confusion is they are not giving in the form of structure. They are giving in the form of wording. So it will be little more confused over here. What is phenyl methyl ketone? What is phenyl methyl ketone? Tell me now, what is phenyl methyl ketone? Yes, this is equal to phenyl group, right? This is ketonic group, this is methyl group. So this is equal to phenyl methyl ketone, right? On treating it with a, which of the following reagent can be converted into phenyl methyl ketone into ethyl benzene? What is ethyl benzene? Benzene ring with the CH2, CH3. This is ethyl benzene. So which of the following reagent can be converted into, you know, C double bond or CH3 into CH2, CH3, right? Yes. What is the answer now? Tell me. So that is zinc amalgam and HCl, right? Zinc amalgam and HCl, right? Got it? I think all of you got it, right? So this is phenyl methyl ketone is nothing but, you know, acetophenone. Phenyl methyl ketone is nothing but acetophenone. They are making little confusion. They are giving common name. So phenyl methyl ketone can be converted into ethyl benzene using zinc amalgam and HCl. So we are moving to the next question. Okay. Yes. Next one. Okay. So we are talking about oxidation of aldehydes and ketones. Let me tell some small concept based on it. Okay. Oxidation of aldehydes and ketones. Listen. What is oxidation of aldehydes and ketones? Who can be oxidized easily? Who can be oxidized with difficulty? So we are discussing. Okay. Listen now. This is equal to aldehyde, RCHO. RCHO upon oxidation, you will get RCOOH. Let me explain a little deeper. See, wait. So, this is equal to aldehyde, RC double bond H, aldehyde. Upon oxidation, you will get R, you can say C double bond OH. Aldehyde upon oxidation, you will get carboxylic acid. This is aldehyde. Yes, students, aldehyde upon oxidation, you will get carboxylic acid, no doubt. This is the oxidation of aldehyde. Oxidizing agents are, which are the oxidizing agents? Oxidizing agents are Tollens reagent or filling solution, or even these are mild oxidizing agents. Tollens reagent and filling solution are mild oxidizing agents. Aldehyde upon oxidation, you will get carboxylic acid, that is Tollens reagent or filling solution is used. Ketone, now you take ketone. This is ketone, right? R, C double bond R. Or I will give an example with this one. CH3, C double bond CH3. Upon oxidation, it requires stronger oxidizing agent like acidified KMnO4 or alkaline KMnO4 followed by H+. So stronger oxidizing agent is required. Strong oxidation. You can cut the bond from here. You will get mixture of acid. How to get mixture of acid? Cut the bond from here. And after that, you can see this side how many carbon? There are 2 carbon atom this side. There is 1 carbon atom this side. So you will get 2 carbon acid plus 1 carbon acid. You will get this. You can break the bond after C double bond O. And after that, count the carbon atom on left side. How many carbon? 2 carbon. And after that, how many carbon here? 1 carbon. Count the number of carbon atom on left and right. Then you can do like that. CH3 C double bond O is there. So it will become CH3 COOH, 2 carbon acid plus 1 carbon acid, HCOH. This is a method of oxidation of ketone. Okay, there are some rules called the Popov rule and everything that we are not discussing here. This is just briefly the basic thing of oxidation of ketone and oxidation of aldehyde. Now the question is, oxidation of aldehyde is easier than ketone. Why? Anybody knows the answer? Why it is so? Yes, I can say the reason now. Oxidation of aldehyde involves the carbon-hydrogen bond cleavage. This bond undergo cleavage. Cleavage means breaking. So oxidation of aldehyde involves the cleavage of carbon-hydrogen bond. Okay, repeating. Oxidation of aldehyde involves the cleavage of carbon-hydrogen bond. Oxidation of ketones involves the cleavage of carbon-carbon bond. Here it involves the cleavage of carbon-carbon bond. This one involves the cleavage of carbon-hydrogen bond, right? So carbon-hydrogen bond is there, carbon-carbon bond is here. So this one involves the cleavage of carbon-carbon bond. This one involves the cleavage of carbon-hydrogen bond, right? Yes, carbon-carbon bond and carbon-hydrogen bond. See now. So now, we can say now, so it involves the cleavage of carbon-carbon bond is stronger normally. Carbon-carbon bond is stronger than carbon-hydrogen bond. So aldehyde oxidation is easy because it involves the cleavage of carbon-hydrogen bond. Ketone oxidation is little harder because it involves the cleavage of carbon-carbon bond. This is a concept you have to learn. It's an important area. It came in board exam before. So repeating, aldehyde can be oxidized easily because it involves the cleavage of carbon-hydrogen bond. And ketone oxidation is harder because it involves the cleavage of what? Carbon-carbon bond. Okay, so this is the method. So now tell me the answer. Anybody can tell me the answer now, fast. What's the answer here? Oxidation of ketone is easier than aldehyde. Wrong. Assertion is wrong. Oxidation of ketone is easier than aldehyde. It is wrong. Oxidation of aldehyde is easier than ketone. So assertion wrong. If assertion is wrong, you have only one option, student. That's so easy. In CBSE, if assertion is wrong, you have only one option. Option D only. So how to do? Yes, CC bond of ketone is stronger than CH bond of aldehyde. Reason is correct. CC bond, you know, carbon can form stable bond with the carbon. Carbon likes other carbon atom. You know, catenation and everything. So carbon-carbon bond is stronger than CH bond. Yes, correct. So assertion wrong, reason correct. Assertion wrong, reason correct. So option D, go for it. I think all of you got it, right? So this key point here is that reason you have to study. Sometimes they may ask any assertion reason question from this concept. Make the concept sure, make the concept clear, then you can do any question. Don't try for question answer type. Make the concept clear, everything will be easy. So here CH bond cleavage is easier, CC bond cleavage is harder. So that's the reason why aldehyde undergoes oxidation easily. Okay, so I think all of you got it. We are moving to the next question, right? Yes, students, is it okay? So we are moving to the next question, right? Okay, good. So we are moving to the next one. See now, what's the next one? Okay, this question also very important topic now. Very important. Which of the following compound will show positive silver mirror test? What is silver mirror test? Anybody? What is called a silver mirror test? Yes, silver mirror test is nothing but Tollens reagent test. What is Tollens reagent? Yes, this is aldehyde. This is aldehyde. On treating it with the Tollens reagent, Tollens reagent is ammoniacal silver-nitrate solution. You will get yellow. You will get silver mirror or black precipitate. You will get silver mirror or black precipitate. Okay, silver mirror or black precipitate. The equation is like that: RCHO plus AgNH3 twice plus AgNH3 twice plus and OH minus. Tollens reagent contain this complex AgNH3 twice plus and alkaline medium OH minus. Okay, so this will react each other. Aldehyde undergo oxidation to produce RCOO minus, and the byproducts are metallic silver, ammonia and water. Okay, these are the byproducts. Silver mirror is due to the formation of metallic silver. Okay, that's it. Silver mirror is due to the formation of metallic silver. So here RCHO, treating it with the AgNH3 twice plus OH minus, you will get RCOO minus plus Ag plus NH3 and H2O. So this is the reaction of Tollens reagent. This is in the form of solution, aqueous solution. So we are getting carboxylate ion. We are not writing carboxylic acid. Actual product is carboxylic acid, but we are not writing carboxylic acid because it is in the form of aqueous solution. So it will be in the form of ions. So RCOO minus. This is equal to Tollens reagent test. So aldehyde will give Tollens reagent test. Who else will give Tollens reagent test? Anybody knows? Yes, there are some exceptions you have to remember. So other than aldehyde, aliphatic aldehyde, Aromatic aldehyde, everyone will give tolerance reagent test. All aldehydes are giving tolerance reagent test. In addition to tolerance aldehyde, this HCOOH will give tolerance reagent test. HCOOH. This is equal to methanoic acid. Students, remember, note down, methanoic acid will give tolerance reagent test. HCOOH. In addition to tolerance methanoic acid, there are some other compounds also give tolerance reagent test, but it is not in CBSE. You can say, in addition to this, you can say, yes, alpha hydroxy ketone, alpha hydroxy ketone, alpha hydroxy ketone, alpha hydroxy ketone will give tolerance reagent test. You remember, like that in biomolecule we studied, glucose is giving tolerance reagent test. Okay. Fructose is also giving tolerance reagent test. Fructose is giving filling solution test because the fructose contain alpha hydroxy ketone. So alpha hydroxy ketone will give tolerance reagent test. In addition to aldehyde, alpha hydroxy ketone. In addition to aldehyde, methanoic acid. This all will give tolerance reagent test. Now coming back to this question. Which of the following will show positive silver mirror test? Silver mirror test is nothing but tolerance reagent test. HCOH will give tolerance reagent test. Yes. CH3, CH2, CHO will give tolerance reagent test. It's an aldehyde. This is alpha hydroxy ketone. When I am asking this one now, when I am expanding this structure, it will be CH3, CHOH. Yes, CHOH. It will be CH3, C double bond O, CHOH, CH3. See this structure if I am talking, this is a functional group. This is equal to alpha carbon, this is a functional group. This is equal to alpha carbon, this is also alpha carbon. It is alpha hydroxy ketone. This is coming under alpha hydroxy ketone. So alpha hydroxy ketone will give tolerance reagent test. So the answer here it is that tolerance reagent test is given by all of the above. See students, this is there in the reader, this is there, but this is not there, but this is little higher level. So remember, alpha hydroxy ketone also will give tolerance reagent test. So the answer is all of the above. Okay, just note down. Okay, so we are moving to the next question now. I hope all of you did this, right? So we are moving to the next question. Okay, yes. Now we are moving to the next question. We studied about, yes, listen, iodoform test. Okay, what is iodoform test we are discussing? We know that iodoform. Tell me students, what is iodoform test? This is based on iodoform test. Who will give iodoform test? Briefly I am explaining. Aldehyde or ketone with CH3 C double bond O group. Aldehyde or ketone with CH3 C double bond O group, right? So aldehyde or ketone with CH3 C double bond O group. Aldehyde or ketone with CH3 C double bond O group. Okay, and aldehyde or ketone with CH3 C double bond O group, or alcohol with CH3 CHOH group. CH3 CHOH group. Alcohol with CH3 CHOH group, or aldehyde or ketone with the CH3 C double bond O group. This is aldehyde or ketone, aldehyde or ketone with the CH3 C double bond O group. This is alcohol with the CH3 CHOH group. On treating it with the NaOH and iodine, NaOH and iodine, or NaOI, you will get yellow precipitate of iodoform. Yellow precipitate of iodoform. This is called iodoform test. We studied already. So aldehyde or ketone with the CH3 C double bond O group, alcohol with the CH3 CHOH group, heating it with NaOH and iodine, or NaOI, you will get yellow precipitate of iodoform, right? That's it, yellow precipitate of iodoform. So now, what is the reaction? I think you know about the reaction. Just doing this equation. Okay, listen now. Do you want equation? Are you okay with equation of iodoform reaction? If you want general equation, I can write. This is equal to RC double bond O CH3, treating it with the NaOI. NaOI is the reactant obtained reagent after reacting with NaOH and iodine. Then you will get, you can say the CH3 part will combine with iodine part. CH3 will combine with iodine part. The CH3 and iodine will combine to form CHI3. That is called iodoform. CH3 part here, iodine part here, combine to form CHI3. Then this part and this part will combine. This part over here will combine with this part to get RCOONA. We can say plus RC double bond ONA. RC double bond ONA. Right? This is the answer. RC double bond ONA. This is the answer to iodoform test. You can remember the equation this way. This is equal to ketone with the CH3C double bond group. The CH3C double bond group with NaOI, CH3 will combine with iodine to produce CHI3. Then RC double bond will react with the NaO to get RC double bond ONA. Right? This is a reaction. So this is the iodoform test equation. You have to remember, student, this is very, very important. See now. Now you may ask how alcohol is giving iodoform test. Yes, alcohol undergo oxidation in presence of NaOI to form ketone, or you can say aldehyde. Then you will get corresponding what? Iodoform test. So alcohol will get oxidized. This will get oxidized to what? This will get oxidized to CH3C double bond group in presence of NaOI, and this group will give iodoform test. Remember this is a condition. So we are going back to the question, right? Yes, listen. Iodoform test is not given by, see, ethanol we are writing. Ethanol is written as CH3 CHOH H. So ethanol will give iodoform test. Ethanol can be written as CH3 CHOH H. So ethanol will give iodoform test, no doubt. The CH3 CHOH group containing alcohols are giving iodoform test. So ethanol will give iodoform test. Remember. Then ethanol can be written as CH3C double bond H. So ethanol will give iodoform test, no doubt. Ethanol contain CH3C double bond group C. Ethanol contains CH3C double bond group. Aldehydes and ketones with the CH3C double bond group will give iodoform test. Ethanol will give iodoform test. Then pentanone I am writing here. Pentanone can be written as CH3C double bond CH2 CH3. So pentanone will give iodoform test, no doubt. Pentanone is giving iodoform test. Sorry, this is pentanone. It should be what? Tell me. It should be CH2 CH3. Pentanone will give iodoform test, no doubt. This is pentanone, that will give iodoform test. Then pentantrione we are talking. What is pentantrione? Pentantrione I can write it as CH3 CH2 C double bond CH2 CH3. So the answer here it is, which is not giving the iodoform test. The answer is pentantrione. Okay, so pentantrione is the answer which is not giving iodoform test. So iodoform test is not given by pentantrione. Students, this is very important area. They are going to ask this area, repeating, who will give iodoform test? Yes, compounds containing aldehyde or ketone with the CH3 C double bond group, or alcohol with the CH3 CHOH group, treating with NaOH and iodine, heating, you will get yellow precipitate of iodoform, right? And this is the equation. These are the compounds. Ethanol will give iodoform test. Remember, ethanol will give iodoform test. This is one and only one aldehyde which give iodoform test is ethanol. Repeating, one and only one aldehyde which give iodoform test is ethanol. Then pentanone will give, pentantrione will not give iodoform test. So our answer is option D, right? Yes. Next question. I hope all of you got it, right? Yes. We are doing to the next question. We are going to the next question. Yes. The reagent which can be used to distinguish acetophenone and benzophenone. Students, we are going to do now. Which is a reagent used to distinguish between acetophenone and benzophenone. What is acetophenone? Easy now. This is acetophenone. C double bond or CH3 is called acetophenone. This is acetophenone. No doubt. This is equal to benzophenone. Benzene ring with the C double bond or CH3. This is equal to benzophenone. Yes. So this is benzophenone. Can you tell me now? This is benzophenone. What's the answer? I want the answer from your side. Read it and tell me the answer. This is benzophenone. Very easy. Very easy question. Tell me. Yes, what is the answer? The reagent which can be used to distinguish acetophenone from benzophenone is, acetophenone will give iodoform test. Okay, benzophenone won't give iodoform test. So we can go for what? Tell me. Iodine and NaOH. The reagent which can be used to distinguish acetophenone and benzophenone is iodine and NaOH. Iodine and NaOH is the reaction. Okay, just go through it. Is it okay, students? Now you may be asking about other options. 2,4-dinitrophenylhydrazine. 2,4-DNP reagent is given by all aldehydes and ketones. So this is not given by aldehyde and ketone. This is given by carboxylic acid. Tolerance reagent is given by aldehyde. Ketones are not giving. Here both are ketones. Ketones will not give tolerance reagent test. So the better one is iodine and NaOH. Okay. So the next question we are moving to do. Next question. Yes, students. Now can you tell me a compound A? I want to know the answer here. This is just like a word problem question. So we are discussing this. Okay. Compound A. You have a compound A with the molecular formula C5H10O. C5H10O. I'll read the question. So a compound A with the molecular formula C5H10O forms phenylhydrazone. Anybody is forming phenylhydrazone? You studied already. Addition with the phenylhydrazine will form phenylhydrazone. That is nucleophilic addition with the removal of water. Anybody is forming phenylhydrazone indicates the compound may be aldehyde. Compound may be aldehyde or ketone. Compound may be aldehyde or ketone. Anybody forms phenylhydrazone indicates the compound may be aldehyde or ketone. With this formula, you can have the compound with aldehyde or ketone. Reason, this is undergoing addition with the phenylhydrazine. Addition with the phenylhydrazine will give you phenylhydrazone, and the phenylhydrazone compound is C6H5. You know, this can be an aldehyde or ketone. Read the second sentence. Negative tolerance. Negative tolerance means this cannot be aldehyde. This negative tolerance means this cannot be aldehyde. No, tolerance reagent is given by aldehyde. So negative tolerance means this formula cannot be aldehyde. No, never. Negative iodoform. Negative iodoform means this compound has no CH3CO group. No CH3CO group. No CH3CO group. Negative iodoform means this compound has no CH3CO group. So what will be the compound? So we know that this compound has formula C5H10O. That compound is an aldehyde or ketone, that is sure. This compound is an aldehyde or ketone, that is sure. But tolerance reagent, they are not giving tolerance. It is not giving tolerance reagent test, so it's not an aldehyde. It is not giving iodoform test. It's not a ketone with the CH3CO. So it can be another ketone which cannot give iodoform test. So with the 5-carbon ketone, which is the ketone with the 5 carbon which cannot give iodoform test. Check ketone with the 5 carbon which cannot give iodoform test. Which one? Yes, very good. So it is CH3, CH2, C double bond O, CH2, CH3. So this is a ketone with a 5 carbon which cannot give iodoform test. So the option will be, which is the option? Tell me now. Yes, it is pentanthreone. The option is pentanthreone. You can say pentanthreone will be the compound. This compound is having the same formula. This compound can do addition with the phenylhydrazine to form phenylhydrazone, no doubt. This compound cannot give tolerance reagent, yes. This compound cannot give iodoform, yes. But it is a ketone without giving iodoform test. So it is pentanthreone. So this is a last year board exam question. Remember, so the answer is pentanthreone. Note down. Next one we are talking. Okay, all of you understood, students? Are you okay with it? Please respond. Yes, so we are moving to the next question. Okay, see next question. Hope all of you got it right. Yes. Now, assertion. Aldol condensation we are talking. Okay, aldol condensation. So what is aldol condensation? We studied already. Final product of aldol condensation is always alpha beta unsaturated carbonyl compound. Yes. Alpha beta unsaturated carbonyl compounds are stabilized due to conjugation. We will discuss this. Okay. So let me discuss aldol condensation in short time. Wait. Who will give aldol condensation? You know that aldol condensation is given by aldehydes with alpha hydrogen atom. Aldehydes with alpha hydrogen atom will give aldol condensation. So who will give aldol condensation? Repeating, aldehydes or ketones with the alpha hydrogen atom will give aldol condensation. We know that. So this is an aldehyde, CH3, CH2, CHO. This is the functional group. Right? That's a functional group. The carbon atom next to the functional group is equal to alpha carbon. This is equal to alpha carbon. Right? Alpha carbon, yes, no doubt. That is alpha carbon. Hydrogen on alpha carbon atom is equal to alpha hydrogen. So this is alpha hydrogen. So this compound has this an aldehyde with alpha hydrogen. It will give aldol condensation, no doubt. This compound will give aldol condensation, no doubt. This compound will give aldol condensation again. Yes, this is a functional group. This is the alpha hydrogen. This is the alpha carbon. Okay, alpha carbon and alpha hydrogen. This will give aldol condensation. So condition for giving aldol condensation is presence of what? Alpha hydrogen atom. So presence of alpha hydrogen atom is the condition for giving aldol condensation. It can be an aldehyde, it can be a ketone, right? So this ketone, CH3, C double bond O, CH3, this is the functional group here. This is the alpha carbon here, this is also alpha. It has alpha hydrogen, so such compounds are giving aldol condensation, right? Yes. So we are moving to do now what is aldol condensation. Shorter way I am telling now, wait. I am just erasing this. I think you people got it. I have to write the reaction here. There is no other space. I am writing here. Listen. So now what is aldol condensation? How to do aldol condensation? See, I am just erasing this. Okay. So whenever I am writing aldol condensation, what's the easy method? Telling an easy method, listen. This is equal to, we can say CH3, CHO, CH3, CHO. Okay, one molecule of aldehyde. Then we are doing another molecule of aldehyde. What is another molecule of aldehyde? I have CH3, CHO, CH3, CHO. Heating in presence of concentrated alkali, concentrated NaOH. It can be any alkali, it can be BaOH twice, it can be CaOH twice, it can be concentrated alkali. What is happening? How to get the final product? I am talking about how to get the final product. Okay, see, final product I am telling. So, remove hydrogen from alpha carbon atom. You can remove hydrogen from alpha carbon here. Here remove H2. Remove H2. Remove hydrogen from alpha carbon. Alpha carbon. Identify the alpha carbon. Remove hydrogen from it. Remove oxygen from functional group. Remove oxygen. Remove oxygen here. Remove oxygen from functional group. Connect through double bond. Connect through double bond, right? So what is after connecting through double bond, what is your answer here? See students, remember, after connecting through double bond, we will get CH3, CH part from first molecule. CH3, CH part from first molecule. Yes, no doubt. CH3, CH, we removed oxygen from here. And CH, CHO from other part. Connect through double bond means double bond is required. You will get CH3, CHO. This is equal to the unsaturated aldehyde. This is equal to, the reactants. One of the reactant is behaving as nucleophile. This is behaving as nucleophile. This is behaving as what? Electrophile, right? One of the carbon atom is behaving as nucleophile. Other carbon atom is behaving as electrophile. We are removing hydrogen from here, oxygen from here, connecting through double bond. See then, you will get concentrated NaOH. You will get CH3, CH, double bond CH-CHO. This is your answer. So this is equal to unsaturated aldehyde. Unsaturated aldehyde. Okay. Now how to get the intermediate? If you want intermediate, I can tell. If you want intermediate, how to get intermediate? Listen. If you are not heating, you are just, this is concentrated NaOH and heating together. So aldehyde or ketone with alpha hydrogen atom. Heating it with a concentrated NaOH, you will get unsaturated aldehyde. What's the intermediate? How to get intermediate? Listen. To get the intermediate, what we are doing, listen. To get the intermediate, we are adding water here. We are adding water in such a way that, yes, here hydrogen is added to this alpha carbon and beta carbon. To alpha carbon, hydrogen is added. Beta carbon, water is added. So that you will get the product here, CH3, CHOH, then CH2, CHO. This is the intermediate. So this is the intermediate you got. So intermediate obtained is like that, CH3, CHOH, CH2, CHO. This is equal to beta hydroxy aldehyde, or we can call it as aldol. This is the aldol. Okay, beta hydroxy aldehyde. So intermediate obtained is equal to beta hydroxy aldehyde. So aldehyde, 2 molecules, this is the method. Now can you read the question now? Tell me. Yes, this is a last year board exam question. Final product in aldol condensation is always alpha beta unsaturated carbonyl compound. Yes, correct. Assertion is correct. No doubt. So final product of aldol condensation is always alpha beta unsaturated carbonyl compound. No doubt about it. Reason. Alpha beta unsaturated carbonyl compounds are stabilized due to conjugation. Stabilized due to conjugation. Yes, they are stabilized due to conjugation. See, what is conjugation here? I'll tell you. This compound is stabilized by conjugation. What is conjugation? Listen. This is CH3, CH double bond CH. This is C double bond OH. This is equal to final product, that is unsaturated aldehyde. This is double bond. This is another double bond. These two double bonds are separated by single bond. These two double bond. This is a double bond here. Yes, this is a double bond here. This is a double bond here. This is another double bond here. Separated by a single bond. Separated by a single bond. Any compound where double bond and double bond separate by single bond, we can call it as, it is called conjugated double bond. This is called conjugated double bond. See, such a compound will show resonance. So it is stabilized by resonance. So if you have double bond, another double bond, separated by a single bond, such a double bonds we call it as conjugated double bonds, and these conjugated double bonds are separated by here these two double bonds are separated by single bond. Such a double bonds are conjugated double bonds, and the molecule with the conjugated double bonds are highly stable. They will show resonance. Now see the second one. Alpha beta unsaturated carbonyl compounds are stabilized due to conjugation. Correct. So assertion is correct. Reason is correct. We can say both assertion, reason are true, but it is not the correct explanation. So we can go for option B, right? Option B is your answer. Both assertion, reason are true, but reason is not the correct explanation. Remember, okay? I think all of you got it, right? So the answer is option B. Assertion correct, reason correct, not the correct explanation. Okay, all of you got it? Students, are you okay? Little bit late, right? So we started little late. That's why I'm going to finish 2-3 questions. Okay, so complete fast. Now we are talking what is cross-aldol condensation. Yes, in cross-aldol condensation there are two different aldehyde or two different ketone. See, I'm discussing this in next question. What is the answer here? This question came in the last year board exam. C6H5CHO, CH3COCH3. What's the answer here? This is an aldehyde. This is an aldehyde. This is a ketone. In presence of concentrated alkali, aldehyde or ketone in presence of concentrated alkali, one has alpha hydrogen, other has no alpha hydrogen. So such a reaction, the aldol condensation between two different aldehyde or two different ketone or ketone and aldehyde. Remember students? So aldol condensation between two different aldehyde, two different ketone, and one aldehyde and one ketone is called cross aldol condensation. Here condition is that at least one compound must have alpha hydrogen. So this is called cross aldol condensation. Okay, at least one compound must have alpha hydrogen. That's the condition. So this reaction is called cross aldol condensation. This has alpha hydrogen. This has no alpha hydrogen. So the reaction is called cross aldol condensation. This is equal to unsaturated ketone. Remember. Okay. Remember that. Just complete it fast. So we are moving to the next question. Okay, I think all of you got it, right? We are moving to do the next question. Okay, listen. Which of the following does not give Cannizzaro reaction? So Cannizzaro, I am talking very faster way. Listen, what is Cannizzaro reaction? Who will give Cannizzaro reaction? Yes, this is aldehyde without alpha hydrogen. Aldehyde without alpha hydrogen. This is another aldehyde without alpha hydrogen. So this is another aldehyde without alpha hydrogen. So aldehyde without alpha hydrogen will give Cannizzaro reaction. We know that. These are the aldehydes without alpha hydrogen will give Cannizzaro reaction. Can you tell me what's the answer here? Which of the following does not give Cannizzaro reaction? This aldehyde CH3 thrice CCHO. This is nothing but this. This aldehyde is this one. CH3 thrice CCHO is this aldehyde. This aldehyde has no alpha hydrogen. This is a functional group. Yes, students, I will explain. This is a functional group. Yes, this is a functional group over here. This is equal to alpha carbon. There is no hydrogen over here. So this aldehyde has no alpha hydrogen. This aldehyde, this carbon atom has no hydrogen. There is no alpha hydrogen. This aldehyde has no alpha hydrogen. All aldehydes without alpha hydrogen will give Cannizzaro reaction. Which of the following will not give Cannizzaro reaction? This will give Cannizzaro reaction. This will give Cannizzaro reaction. This will give Cannizzaro reaction. This will not give Cannizzaro reaction because this aldehyde, if I am expanding, what will be the answer? It will be CH3, CH, CH3, CHO. So this is the functional group. Yes, this is the alpha carbon, alpha carbon, alpha carbon. So this is the functional group. This is equal to alpha carbon. There is alpha hydrogen. Okay, that's the answer. Alpha hydrogen is there. So this will give this will not give Cannizzaro reaction. So the answer is option B, right? Option B. So option B is like that. CH3 twice CH, CHO will not give Cannizzaro reaction. Go and study the equation for Cannizzaro. Lack of time I'm not doing. So I have to finish 2-3 questions. Okay, we are a little bit late now. So just complete it. All of you completed? Yes, students, tell me fast. Are you okay with it? Yes, we are moving to the next question, right? So which of the following has lowest pKa value? We are going to study about, you know, you studied already. I'm just telling the answer only. So which of the following has lowest pKa value? We know that Ka value directly proportional to acidity. pKa value inversely proportional to acidity, right? So Ka value directly proportional to acidity. pKa value inversely proportional to acidity, right? Yes, Ka value directly proportional to acidity. pKa value inversely proportional to what? Acidity, right? Yes, we are discussing. Now, so, now which of the following has highest pKa, lowest pKa value? So lowest pKa means more acidity. Acidity will be more. Acidity will be more. So they are indirectly asking which is more acidic. Tell me the answer. Anybody can tell me the answer fast? Yes, students? Yes. Okay. It's good. Good. Is option B, right? Okay, very good. So option B, how it came like that, we will discuss. Okay. So who can increase the acidity? We studied. This is the order of increasing acidity. Remember. So you can note down. CF3 will increase acidity maximum. Then NO2, then NO2, then CN, then CN, then fluorine, then chlorine, then bromine, then iodine, These are the area it will increase acidity. Then benzene ring. This all will increase acidity, students. This is the order of increasing acidity. So CF3 can increase maximum, then NO2, then CN, then fluorine, then chlorine, then bromine, then iodine, then benzene ring. So here who will increase acidity more? Yes. So CH3COH, there is no electron withdrawing group. We know that presence of electron withdrawing group will increase acidity. These all groups have minus I effect. These all groups have minus I effect. Or these all groups are electron withdrawing groups. These all groups will increase acidity. We studied before. Okay. these all groups will increase acidity. So NO2 will increase acidity, CN will increase acidity, fluorine will increase acidity, this all will increase acidity of carboxylic acid, this all will increase acidity of phenol, this all will increase acidity of alcohol. So this all can increase acidity of any compound. So remember. Now here CH3, NO2 is the answer here. NO2 has more electron withdrawing effect. NO2 has more electron withdrawing effect. So NO2 with the CH2COH will be more electron withdrawing. So the answer is B, right? Remember that. Got it? So NO2 will increase the acidity. So NO2 with the CH2COH will be the answer. Option B is your answer. Go through it. Okay, learn this. This is the order of increasing acidity. These all groups, presence of electron withdrawing group increases acidity. Okay. Next one we are talking. Students, are you okay with it? So we are moving to the next question, right? Okay then. So assertion, alpha hydrogen atom of aldehydes and ketones are acidic in nature. Reason, conjugate base formed by losing alpha hydrogen is stabilized by resonance. Anybody can tell me the answer? We discussed this one in the class. Even today we discussed. Can you tell me the answer? Anybody? We discussed this topic in revision. Tell me. Yes, tell me the answer. Hiba, tell me. What's the answer here? We will discuss. Okay. What is this alpha hydrogen atom of aldehyde? This is a board exam question, last year board exam question. See, we will discuss. Okay. Now, alpha hydrogen atom of aldehyde and ketones are acidic in nature. See, this is equal to CH3, CHO. This is the functional group. Okay. This is equal to alpha carbon. This is equal to alpha hydrogen. So they are acidic in nature. Yes, correct. They are acidic in nature. Alpha hydrogen atoms are acidic in nature. That's the reason they are showing aldol condensation and everything. Aldol condensation is a perfect example of, you can say, acidic nature of alpha hydrogen. They are generating nucleophile by releasing H+. So this alpha hydrogen atom is acidic in nature, correct? That is correct. Alpha hydrogen atom is acidic in nature, no doubt. Alpha hydrogen atom is acidic in nature. Why? Yes, we will discuss why. Listen now. So this compound I can write it as CH3, C double bond O H. This is equal to aldehyde. After losing alpha hydrogen, it will convert it into H plus and CH2, C double bond O H, CH2 minus. This generated species after losing H plus. See students, the species generated after losing H plus is called conjugate base. This is equal to conjugate base. Told you, the species generated after losing H plus is called conjugate base. So this is aldehyde. After losing H plus, it generates a species, alpha hydrogen atom is giving out. So after losing H plus from alpha carbon, so the generated species we call it as conjugate base. See now, conjugate base, there is a conjugation between, you can say, the lone pair electron and double bond. Here you can see this particular compound, lone pair is in conjugation with the double bond. This is the lone pair, this is the double bond. This double bond and lone pair are separated by a single bond. These two are separated by a single bond. When these two are separated by a single bond, we can say that there is a conjugation between the lone pair electron and double bond. It is stabilized by resonance. So condition for resonance we studied, double bond conjugation, double bond lone pair electron conjugation, double bond positive carbon conjugation. If these conjugations are there, the compound can show resonance. Double bond and double bond separated by a single bond. Double bond and lone pair separated by a single bond. Double bond and positive charge carbon separate by a single bond. They will show resonance. Remember. So double bond conjugation, double bond positive charge carbon conjugation, double bond lone pair conjugation, the compound will show resonance. What is conjugation? Conjugation means this point and this point. Conjugation indicates separated by this single bond. There is a single bond. So this point and this point separate by a single bond, that is equal to conjugation. So this compound is stabilized by conjugation. So now we will read the assertion reason. Alpha hydrogen atoms of aldehydes and ketones are acidic in nature. Yes, no doubt. So conjugate base formed. This is a conjugate base generated. That formed is, you can say, formed by losing alpha hydrogen is stabilized by resonance. So assertion correct, reason correct, correct explanation. So option A. Your answer is option A. Note down. This is an important question. Note down. Now we are moving to do next. Okay. Hope you got it right. All of you are okay with it, students? Please respond. So we are moving to the next question, right? Yes. So we are moving to do the next one. Got it? Yes. So we are moving to the next question now. Benzoic acid does not undergo Friedel-Crafts reaction. Okay. Benzoic acid does not undergo Friedel-Crafts reaction. This is a repeated question in the board exam. Most time a repeated question I can say. Benzoic acid cannot undergo Friedel-Crafts reaction. This is benzoic acid. Okay. Benzoic acid. Or I can write this benzoic acid as, I can write benzoic acid as benzene ring with a C double bond O OH. Right? Okay. Benzoic acid is not undergoing Friedel-Crafts reaction. Why? See students, in Friedel-Crafts reaction we are using a reagent namely aluminum chloride. It's a catalyst, anhydrous aluminum chloride we are using. See now. So whenever we are treating this is benzoic acid. Number one reason why benzoic acid cannot undergo Friedel-Crafts reaction. This is an important question. In Friedel-Crafts reaction, we are treating it with CH3Cl in presence of AlCl3. No reaction. Why? What's the problem with them? What's the reason? Number one reason, they are less reactive. They are deactivating. This carboxylic acid group is deactivating. Deactivating means it has, it has minus R effect. So minus R effect will deactivate the ring. At least for the being time, you remember it is deactivating. It is, less reactive than benzene. One reason is it is less reactive than benzene. Number one. Number two reason we can say, in Friedel-Crafts reaction, we are using AlCl3. What's the problem with AlCl3, students? AlCl3 is an electron deficient compound. See, when you are drawing the structure of aluminum chloride is forming 3 covalent bond. Students, number of electron present in one covalent bond is 2 electron. This has 2 electron. Yes, aluminum chloride, this molecule has 2 electron here, 2 electron here, 2 electron here. Total number of electron will be 6 electron after the bond formation. So this compound is electron deficient compound. So aluminum chloride is an electron deficient compound. Suppose I am asking to aluminum chloride, hello Mr. Aluminum chloride, how do you do? He's telling I'm not happy. When he approaches the doctor will check and tell, yeah, you have one problem. You have electron deficiency. So the aluminum chloride is a compound with electron deficiency, right? So that's a big problem with aluminum chloride. If anybody is electron deficient, that will be unstable. So it will be seeking electron. So aluminum chloride is a referee here. Aluminum chloride is a catalyst here. His problem is electron deficiency. He is seeking electron. He finds the electron pair here. This is the electron pair on carbonyl oxygen. This oxygen we call it as carbonyl oxygen. Carbonyl oxygen. Got it? This oxygen we call it as what? Carbonyl oxygen. Yes, this carbon atom connected to oxygen is called the carbonyl oxygen. So aluminum chloride has affinity towards electron pair. So this aluminum chloride will attack the carbonyl oxygen, so that aluminum chloride will not catalyze the reaction. Think like that. A referee is not playing. So here you can say a referee is there. This is a referee for controlling the game or controlling the football match. Think like that. A referee is going somewhere. What to do? The match will not happen. So this is the way. So aluminum chloride is reacting with the, you can say, the lone pair electron. So it is attacking the carbonyl oxygen. That's very important point. So this is the two reason why benzoic acid cannot undergo Friedel-Crafts reaction. Number one reason, benzoic acid is deactivating. Number two reason, aluminum chloride used in Friedel-Crafts reaction is attacking the carbonyl oxygen. Now coming back to this assertion reason question. Can you tell me the answer? Benzoic acid does not undergo Friedel-Crafts reaction. Correct. Assertion correct. No doubt. Assertion is correct. Reason. Carboxyl group is deactivating and gets bonded to Lewis acid AlCl3. Yes, correct. Carboxyl group. Actually, carboxyl group is deactivating and AlCl3 is attacking the carbonyl oxygen, get bonded to AlCl3. Yes, it's correct. So assertion correct, reason correct, correct explanation. So our answer is option A. Assertion correct, reason correct, correct explanation. Okay. Hope all of you got it. You can note down. This is very important area. Most time a repeated question in board exam. Sometimes assertion reason, sometimes give reason, like that. Okay, just study it. This is very, very important. Now last one we are talking. Hope all of you got it, right? It's too late today. What to do? Last one. Okay. Last one. Anybody can tell me the answer for here? Assertion. Acetic acid but not formic acid can be halogenated in presence of phosphorus and chlorine. What is acetic acid? Acetic acid is, this is equal to formic acid. This is equal to formic acid. This is equal to acetic acid, CH3COH. This is equal to acetic acid. Now they are telling acetic acid, not formic acid, is halogenated in presence of phosphorus and chlorine. You study about HVZ reaction. You remember, student, what is HVZ reaction? Yes, this is HVZ reaction. We have a carboxylic acid with alpha hydrogen. We are treating it with a phosphorus bar X2. It can be chlorine or bromine. X can be chlorine or bromine. So this hydrogen is replaced by halogen. You will get RCH X, then COOH plus HX. This is equal to HVZ reaction. We study this reaction, HVZ reaction. This is very, very important. This is carboxylic acid. This carboxylic acid functional group is equal to, this is functional group. This is equal to alpha carbon. This is equal to alpha carbon. Alpha carbon. This is alpha hydrogen. When you have reaction with the phosphorus and halogen, you will get a license to remove hydrogen and replace it by halogen. You will get a license to remove this hydrogen, replace it by halogen, right? So then you will get RCHXCOH. This is a reaction. RCHXCOH plus HX. Okay, this is equal to HVZ reaction. Now coming back to this question. HVZ reaction is given by carboxylic acid with alpha hydrogen. This will not give HVZ reaction. No, this says there is no alpha hydrogen. This is a functional group. There is no alpha carbon. There is no alpha hydrogen. This is a functional group here. This says alpha carbon. Alpha hydrogen is here. So this will give HVZ reaction. This acetic acid will give HVZ reaction. Okay, now coming back to the question. So acetic acid but not formic acid can be halogenated in presence of phosphorus and chlorine. Assertion correct. No doubt assertion is correct. Acetic acid but not formic acid can be halogenated in presence of phosphorus and chlorine. Yes, acetic acid will give HVZ reaction. It can be halogenated using phosphorus and chlorine. Acetic acid is a weaker acid than formic acid. That also correct. Acetic acid is a weaker acid, no doubt. So acetic acid contains CH3COH. Then acetic acid is a weaker acid than, acetic acid is a weaker acid than formic acid, no doubt. Now, we can say assertion correct, reason correct, not the correct explanation, not the correct explanation. So I can say option is B, right? Assertion correct, reason correct, not the correct explanation. All of you got it? So this is about the topic. I think I completed all questions. Any doubt in between you can ask me. So we are concluding now. So we'll come with another chapter next day. So we'll cover all chapter before your, board exam. Okay. So just go through these all questions. These questions are really, really important. So we'll see you next day. Bye then. See you.